The number one question I get asked, especially at this time of year, is what exactly do I need to do to achieve my target grade in GCSE maths? And that's the right question to be asking, because if you're studying 10 subjects and revising for around 3 hours a day, that gives you just 18 minutes per subject, if you split your time evenly. So you can't afford to revise everything. You need to focus on the topics that will move your grade the most. That's exactly why I built TGMT Live, a structured library of resources designed to help you maximise your grade in minimum time. Everything is organised by exam paper, so you know exactly what to revise and when to revise it, instead of guessing and hoping for the best. Live, interactive revision lessons focused on the key topics you need to prioritise this year. Paper-specific revision quizzes that generate 2 reports, giving you a clear, personalised revision plan. A fully organised lesson library, broken down into units, so you can go straight to the exact topics you need and track your progress. Priority access to revision booklets with work-along videos for deeper topic understanding. Priority access to practice papers with work-along videos focused on high-impact exam questions. Paper-specific checklists, plus an 84-page ultimate revision guide. So if you're feeling overwhelmed by how much there is to revise, TGMT Live gives you a clear system to follow. A one-stop hub for paper-specific GCSE maths revision, built around efficiency, and getting the maximum result from the time you actually have. Okay, so looking at our first question on using a calculator. Now with using a calculator, we just need to make sure it looks exactly the same. So here we've used our fraction button, we've then typed in the cube root, and we're using our blank power button, making sure we come out of the power here before pressing the tan button. We don't need to put that degree symbol in. So onto the bottom of the fraction, 9 to the power of a half. Once we've typed it in and we're happy it looks exactly the same as it does on the paper, we'll press equals. This question wants us to round to 3 significant figures, so we'll chop after the 1 here, so that'd be 0.482 as our final answer. So just making sure it looks identical to however it does on the page. Now for our next question, we are looking at lowest common multiple and highest common factor. So here there are multiple different methods we can use to find the lowest common multiple. I'm just going to write out a list of the times tables. Particularly as 40 ends in a 0, I know if I go up in 56s, just typing them into the calculator, then I will spot a number that divides by 40. Now, as we are going up in 56s here, it's a little bit awkward in terms of doing the numbers, but I know it's going to be either the 5th number along or it's going to be the 10th number along, as they're going to be the numbers that end in a 0. So here the 5th number along is 280. I just need to divide that by 40 to see if that's also in the 40 times table, and as it happens it divides by 7 times. So here on the 40 times table we know we're going to get along to 280, and therefore our lowest common multiple is 280. For the next part, where we are looking at the highest common factor, we've been given our numbers in product of prime factor form. Now in order to work out the highest common factor, you could type these numbers into the calculator. 2 cubed times 3 times 5 is 120. However, we can just write these in the long form by writing 2 cubed as 2 times 2 times 2, and then we have times 3 times 5. For the next one we have 2 times 2 times 3 times 5 times 5, and all we need to do is identify the numbers that are in both. So they both have a 2, they both have a second 2, they both have a 3, and they both have a 5. So when we are finding the highest common factor, these numbers that are in both 2, 2, 3, and 5, all we need to do is multiply those numbers together. So 2 times 2 times 3 times 5, On the calculator that comes out as 60, and that is our highest common factor. Now if you did type these numbers into a calculator as well, you would have found that this one here is 120, and 2 times 2 times 3 times 5 times 5 is 300. So there we go, we've just found that 60 is the highest common factor of 120 and 300. And of course, if you're not given the numbers in prime factor form, you can write down the factor pairs and identify which is the highest, or of course, you could actually turn them into prime factor form and then use this method as well. So looking at some product rule for counting. It says here there are 95 girls and 87 boys. One girl is going to be chosen for the role of head girl, and a different girl is going to be chosen for the role of deputy head girl. And then we have the same options for the boys. It says work out how many different ways this can be done. Now with the product rule for counting, and the hint is in the title for this, product means to multiply. So all we have to do is find the different options in each scenario, and we'll multiply them all together. So here we have one girl is going to be chosen, and that's out of 95 girls. Now a different girl is going to be chosen for head girl. So once the head girl's been chosen, the deputy head girl, there's only going to be 94 options. With the boys, there is 87 boys, and once the head boy has been chosen, there will only be 86 choices. Now, if we wanted to find the combination of the different girls that could be chosen, we'd just do 95 times 94. However, for each of those different combinations of girls, there is then one head boy which is going to be chosen, which means we need to multiply that by 87, and then there's 86 boys that could be chosen for the deputy head boy. So all we have to do is multiply all of these together. 95 times 94 times 87 times 86. We are going to get a very large number here, but our final answer is 668,14260. There we go, that is 66,814,260 different options. Now in this question we are looking at some standard form. If we need to convert numbers in standard form, it might be that if you type it into the calculator, it'll do it for you. So this particular number here, it comes out as a fraction, so if we convert that, this one on my calculator does come out in standard form. If it doesn't, you just write the number down, hop that decimal so it's between 1 and 10, and this one has a negative power as it's a 0-point number. For the next part of this question, we have quite a large sort of fraction to type in under this square root. We need to put these numbers that are in standard form into the fraction, being careful to put our negative power in, and then coming out of the top onto the bottom. And this one has d cubed on the bottom. So I'm going to put this one in brackets, 1.4 times 10 to the negative 4, and then once I close the bracket and make sure we come out of the power, then I can put my cubed in, and there we go, we have our power of 3, pressing equals, and we will get our answer. It does want this to 3 significant figures, so we'll write that down, drop it after the third number, so that'd be 4,520. And then we need to hop the decimal back in 3 jumps to make it 4.52, and that'll be times 10 to the power of 3. Now on to some reciprocals and error intervals. Now when you're finding the reciprocal of anything, all you need to do is flip it over. However, if it's not already written as a fraction, then when we flip it over, we just imagine that it's sat over 1. So flipping that over would become 1 over 1.6. Now we can't leave that as a decimal within a fraction, and it does say to give your answer as a decimal. So if we just type that into a calculator, you can type it in as a fraction, or 1 divided by 1.6. It comes out, and on my calculator, it turns it into 5 over 8. I'll use my conversion button, and that turns it into 0.625. And there we go, that is our reciprocal of 1.6. For the next part here, we're looking at an error interval. It says that Jessica rounds a number, x, to 1 decimal place, and the result is 9.8. Write down the error interval for x. So when we are looking at error intervals, 9.8 to 1 decimal place is actually between the two numbers 9.7 and 9.9. When we're looking at error intervals, we want the cut-off points that's in between those two, in order for it to round to 9.8. So in between 9.7 and 9.8 is 9.75, and in between 9.8 and 9.9 is 9.85. So that's our lower bound and our upper bound, which will go into our error interval. So on the left we have 9.75, and on the right we have 9.85. And there we go, there's some error intervals. Now when looking at bounds, we do have a lot to type into a calculator. It's not overly complex to type this into the calculator, it's just getting those error intervals correct and using the correct bounds. So when typing this into a calculator, it does look very similar to a previous question, so we won't use a calculator, well we will use a calculator but not on the screen for this one, as it's relatively nice to type in. So here we have E is 6.8, correct to one decimal place, and using error intervals for that, E is therefore going to be between 6.85, adding that 5 on the end, and 6.75. I'm just dropping that down by 1 for the 8 and then sticking the 5 after it as well. For 0.05, not as nice actually to write the error interval for, but that's going to be 0.055 and 0.045. And there we go, there are our error intervals. It says here to work out the upper bound for the value of p. So to get the upper bound, which is the biggest possible answer, we want to have the biggest possible answer here on the top divided by the smallest on the bottom. So this will be the upper bound on the top and the lower bound on the bottom. So E, we want to use our biggest possible number. So for E, we're going to use 6.85, and for F, we want the smallest possible answer, so 0.045. So what we need to do is type that into our calculator. So we're going to do the square root of 2 times 6.85, and on the bottom we're going to do 0.045. Once we've typed that in, it does want us to give our answer to 3 significant figures, but if we type that into the calculator, 2 times 6.85 on the top, and 0.045 on the bottom, making sure it's all underneath the square root, we get a final answer which comes out as 17.448336644. I've written the whole number down, now I'm going to round it to 3 significant figures, which is just after the 4 there, so that comes out as 17.4, and that is our upper bound. Now again, if we were asked to work out the lower bound here, then you would put the smaller number, or the smaller or the lower bound of E on the top, and the upper bound of F on the bottom. If we were asked to consider bounds, then we'd actually work both of them out and see if they round the same. So just read the language very carefully in these questions, but there we go, this one just wanted us to find the upper bound. Okay, so looking at some expanding and factorising. Now here we have 2 sets of single brackets to expand. We just need to be really careful on this one as we have got a subtraction there in the middle. So for the first bracket, we have a nice expansion, just multiplying those by 5. So that'd be 5p plus, and then we have 15. Now for the second bracket, there are 2 ways to approach this. We can either multiply everything in the bracket by 2, and then remember to subtract them, which just means we have to think a little bit more carefully, as there is a negative 2p there. And when we're subtracting a negative, it will turn into a positive. So you just need to be really careful. Now I prefer to just multiply by negative 2 straight away. Then I don't have to think about that process later on. So negative 2 times 1 is minus 2, and negative 2 times negative 2p would be positive 4p. And now we can collect those like terms together. So we have 5p, add 4p, so in total we are going to have 9p. And then we also have the 15 here, take away 2, which leaves us with 13, so that's plus 13 in total. And there we go, we get 9p plus 13. Now this next part here is a little bit of a strange quadratic. We have a squared minus b squared. We're being asked to factorise that. Now this is very similar to a difference of 2 squares, a normal quadratic that we would see, something like x squared minus 16. And hopefully if you saw that one, you would know that that is x plus 4 and x minus 4 in the brackets. Now this is exactly the same above. It's a difference of 2 squares. It's just a squared and b squared. So we'll factorise this in the same way. We'll have a plus b and a minus b. And there we go, that's factorised. And if you were to expand that, you get a squared, then you get minus ab plus ab, and they cancel each other out, and then the minus b squared. It says hence or otherwise, simplify fully, and then it's given us basically the same thing, except there's loads of pieces in the bracket. Now this here, we have this x squared plus 4, that's just our a. And then we have this x squared minus 2, and that would be our b. So all we need to do is replace the a's and b's in our previous answer, the a plus b, a minus b, with these new pieces. So if we start with the a plus b, well, a is x squared plus 4, so x squared plus 4, and then we're adding b to that, so adding x squared minus 2, and that's our first bracket done. And in the second bracket, it's a minus b, so x squared plus 4, and here's where you've got to be really careful because we are subtracting b, so minus the x squared, and then we're going to subtract the negative 2. So we're looking at this piece here now, this subtraction of that negative 2, and that would be plus 2. So if we simplify what we have in the brackets, on the left bracket, we have 2x squared, 4 and minus 2 makes plus 2, and that's our first bracket. The second bracket, if we simplify what's in there, we have x squared minus x squared, so that's gone completely, and then the 4 plus 2, which just leaves us with 6. Now normally if we had something written like that, of course we would write that as a single bracket, 6 lots of 2x squared plus 2. And we do want to simplify this. There's two things we could do. We could either expand that, which would give us 12x squared plus 12, or we could go ahead and refactorise it and fully factorise it, in which case we could put 12 on the outside and you could have x squared plus 1 on the inside. Now either one of those answers would be fine. I would probably just leave my answer as 12x squared plus 12. It doesn't say it needs to be given factorised, it just says it needs to be simplified. But there we go, there's some expanding and factorising. Okay, so on to some algebraic fractions. Now in this one we are dividing algebraic fractions. When we are dividing algebraic fractions, we just need to multiply by the reciprocal. So keeping the first one as it is, flipping the second one over, we're going to times them instead. It does say it can be written in a particular form, so we need to be aware of that and just be really careful as we go. But let's have a look at the first fraction. Now the first fraction just has 6x cubed on the top, so that can stay as it is. The denominator here does have a difference of 2 squares, so 9x squared minus 144, 9 and 144 are both square numbers, so that would factorise to 3x plus 12 and 3x minus 12. There we go, just the square root of 9 and the square root of 144 in those sort of replicated brackets where one's a plus and one's a minus. Now it's up to you, we can factorise the second one if it needs factorising. This particular one doesn't look like it actually needs factorising, so we can just flip this over and start to get to a point where we can start to think about multiplying them. So we have 2x to the power of 4 on the bottom and 3 lots of x minus 4 on the top. Now from this point we are kind of looking now to see if anything can actually factorise or cancel off or anything at all. So at the moment you can see that there is a 2x to the power of 4 on the bottom right and a 6x to the power of 3 on the top left. Now we can actually divide both of those by 2 and both of those by the x to the power of 3. So we can cancel those down. If you want to write that in one step, we could say, well, divide the top here by 2x to the power of 3, and we'll divide the bottom here by 2x to the power of 3. Now looking at the bottom left fraction of the fraction and the top right of the right fraction, there's nothing actually at the moment that simplifies there. However, if we expand this bracket, we get 3x minus 12, and that does match one of the brackets on the bottom left on the left fraction. So they're going to cancel off as well. So actually we can divide by 3x minus 12. That's going to cancel off this numerator here. When we divide by 3x minus 12, as there's only 3x minus 12 there, that will just turn into 1. And this 3x minus 12 here will disappear. So that's all the kind of thought process as to what we can cancel off to start with. So we need to write what we've actually got left once we do that. We'll still keep it as two fractions for the moment. So here, 6x to the power of 3 divided by 2x to the power of 3, well that fits in 3 times. So we have 3 as our numerator. On the bottom, we just have that 3x plus 12 as the 3x minus 12 has now cancelled off. We don't need to keep it in brackets anymore because there's nothing else with it. We're going to multiply that, and on the right fraction we have 1 on the top as we've cancelled off that 3x minus 12, And on the bottom, we have 2x to the power of 4 divided by 2x to the power of 3. Well, that just is x, as it's x that you have to times by 2x cubed to get to 2x to the power of 4. So that's what we're left with. We now just need to expand this, or expand the brackets on the top and the bottom. Now on the numerator, it's 1 times 3, so no bracket there, just 3. On the denominator, it's x multiplied by 3x plus 12. So that'll give us 3x squared plus 12x. Now we're kind of getting there, but this does want it in a particular form. It wants it to be 1 on the top. Now if it wants it to be 1 on the top, that means that the numerator and denominator must divide by 3. And you can see that that denominator does factorise by 3. So we could factorise the bottom by 3, so we can cancel these 3's off, and that would leave us with x squared plus 4x. Now we can actually cancel off the 3's. We will get 1 on the top now when we divide by 3. So if we rewrite that, let's see what it looks like. We have 1 on the top, and we have this x squared plus 4x on the bottom. Now we are almost finished. It does say in the question it wants it in the form on the denominator here, x brackets x plus r. So we just need to factorise x out of the denominator. We've still got 1 on the top, which is what we wanted. On the bottom, we'll have x lots of, x times x makes the x squared, and x times 4 makes the 4x. And there we go. R, or the value of r, is 4, and we've got it in that form that it was asking for. There you go, quite a complex algebraic fraction there, but lots of steps in terms of how to cancel or cross-cancelling in the start, and also cancelling by factorising. And this was quite an interesting one because we actually had to expand the numerator on that right fraction in order to cancel off those common factors. So there we go, a nice interesting algebraic fraction question. For this next algebraic fraction, we are adding or subtracting. In this particular one, we are actually subtracting here. It says show that, and then we have a big calculation to work out. But it says show that it can be written in the form ax plus b over x squared minus 4, where a and b are integers. Now when we are adding and subtracting, the same as just with normal numbers, we do that from left to right. So here we're going to first subtract these two fractions, and then we will deal with that subtraction of 1. So let's just start by doing those. Now we need a common denominator in order to subtract these. So that means we need to multiply this left fraction by x minus 2 and this right one by x plus 2, and that's on the top and the bottom. So if we write that out in sort of a long form, we have 3x multiplied by x minus 2 on my numerator, and that's now over x plus 2 and x minus 2. On the next fraction, we have 2x plus 1 multiplied by the x plus 2, and that's all over the same denominator, x plus 2 and x minus 2. And there we go. So let's just look at expanding these and sort of tidying it all up and just seeing what it looks like, and then we'll think about that one. So for this first fraction, 3x times x and 3x times minus 2. 3x times x is 3x squared, and 3x times minus 2 is minus 6x. The denominator, x plus 2 and x minus 2, we can expand that because it does want it in an expanded form. It says here x squared minus 4, and actually that is a difference of 2 squares anyway, so it does just become x squared minus 4. You can take your time to expand that if you want, but you'll see those two middle pieces cancel out. We need to subtract from that then. Our next one, we already have the denominator, so we can write the x squared minus 4 on the bottom. We just need to expand these double brackets. So 2x times x gives us 2x squared. And to save myself actually too much working out here, I'd probably expand this just to the side so that I can tidy it up and put it straight on the numerator, so I don't have to keep writing this out. So we've got the 2x squared. 2x times 2 is going to be 4x. Then 1 times x plus 1x. And 1 times 2 is plus 2. So we just want to join these middle pieces together. That'll be 5x, so we can write that on the numerator now, plus 5x plus 2. Now we do have to subtract these fractions, so I need to be really careful, because when I subtract the 2x squared, I'm going to be taking that away, I'm going to be subtracting the positive 5x. I'm going to be subtracting the 2, looking at this numerator up here and being really careful with that. So we have 3x squared on the numerator, take away 2x squared, that leaves us with x squared. We have negative 6x, take away 5x, that's minus 11x. And then we have nothing, take away 2, so minus 2. And that's all over x squared minus 4. So that is the first two fractions combined. We've already done an awful lot of work just to get to this point. But now I need to take away 1. Now, with a whole number, I want to write that as a fraction. So I'm going to write that as minus 1 over 1, which seems a little bit strange to do, but we need a common denominator. Now, our common denominator that we're going to need is x squared minus 4. So I'm going to multiply both sides, well, top and bottom, by x squared minus 4. As it is just 1, it is actually relatively nice. They both just come out as x squared minus 4. So if I write that out, so I can deal with this subtraction, on the left we have x squared minus 11x minus 2, all over x squared minus 4, and the right fraction is going to be x squared minus 4 over x squared minus 4. And again, being really careful here because we do have that subtraction again. So when we subtract these, we are going to just need to be really, really careful with those positive and negative symbols. Let's just move this out of the way so we have some space. So what do we get? Well, x squared, take away the x squared. So just looking at these two to start with, they actually cancel out. So they're gone completely. So we have minus 11x, take away, and there's no x's there, so that'll be minus 11x. We have minus 2, take away minus 4. So when we take away negative 4, that's going to add 4. We're starting on negative 2. Again, you can use a calculator for this, but that's going to become plus 2. And then on the denominator, we have x squared minus 4. And there we go, we've joined it all up. Now, normally I would write that as 2 take away 11x on the numerator, but it wants it in the form ax plus b, so we'll leave it in that form there, minus 11x plus 2, all over x squared minus 4. Obviously a very large question there, lots to think about, lots of positives and negatives to be careful of. You can always use your calculator at any point for those positives and negatives, of course, if you're doing a calculator paper. But there we go, there was some adding or subtracting algebraic fractions. So with these styles of negative or fractional indices, when they are in reverse, we need to be very aware of the rules and how indices are used. So in this one here, we have a fractional indice involved, and it says ax to the power 9, and that's all to the power of 1 over n, is equal to 3x to the power of 3. So it says work out the value of a and the value of n. So in this case, with a fractional indice, we're going to need to have a look at which pieces we've been given and how we might get there. So we have been given that there is a power of 9 and it's turning into a power of 3. So we need to think about this 1 over n and how we're going to get from 9 to 3. Now powers in brackets multiply. So this power 9 to the power 1 over n would be multiplied, and that would give us 9 over n, and that's going to equal 3. So in this case, n must be equal to 3, as that's what you divide 9 by to get to 3. So we've got our first one, so we know that that is now to the power of 1 over 3. Now we need to think about the a. How are we going to get from a to 3? Now, a power of 1/3 does a cube root. So a to the power of 1/3 is going to be equal to 3. And that's almost a reverse root. So we're thinking what number cube rooted is going to equal 3? Well, to reverse that, if we write it as the cube root of a is equal to 3, well, we would have to cube both sides to get rid of that cube root. So a would be equal to 3 cubed, and 3 cubed is equal to 27. So a must be equal to 27. Now, if you're not 100% sure, of course, you've got to know these power rules very well, your laws of indices, but now we would have 27 x to the power of 9, all to the power of 1/3. Now, working forwards with this question, we would do the cube root of 27, which is 3. And the power of x we would times by a third. So x to the power of 9 times a third. And that would give us x to the power of 3. And that's exactly what was given to us in the question. So there we go. For this question, a was equal to 27 and n is equal to 3. So we've got some changing the subject here where we have roots and powers involved. It says here to make k the subject of the formula. Now, if everything is underneath a square root or a cube root, the first thing we need to do is to unlock what's underneath by getting rid of the root. The way to get rid of a square root is to square both sides. So the first step is relatively nice because if we square both sides, well, the left side would become m squared, and the right side here, we were just getting rid of that square root. So we're just going to write what's underneath it, k cubed plus 1 all over 4. We now have a fraction, which is stopping us from moving pieces on the numerator. So to get rid of the fraction, we're going to need to multiply by 4, as that obviously means dividing by 4 on the bottom. That's going to remove this divide by 4. And then on the left, we will have 4m squared now. And that's now equal to k cubed plus 1. Now at this point, you've got two options. We could cube root. However, I do like to do the powers last there, as normally you do powers first when you're going forwards, but we are doing the inverse. But you just need to remember you'd have to cube root everything. So instead of doing that and forgetting to cube root things, I'm going to subtract this 1, and that will leave me with 4m squared minus 1 is equal to k cubed. We can now think about removing that cube by cube rooting both sides. If we cube root the left now, we get the cube root of 4m squared minus 1, and that is now equal to k. And you can write that the other way around if you want. You can write k is equal to, and it might say k equals on your dotted line, k equals the cube root of 4m squared minus 1. And on to some changing the subject with factorising. So it doesn't tell us in the question we're going to need to factorise, but the big hint that we've got a more difficult version here is the fact that there is an a in two places, and that's what it wants us to make the subject. So we have an a here and an a there. So it's not sufficient just to minus the 3 and then have it as a equals because there's another a on the other side of the equal sign. So we need to get all the a's on the same side. To do that, we're going to need to unlock the right-hand side by multiplying by r. So the first thing I'm going to do is multiply by r, and that's going to give us ar plus 3r on the left-hand side. We'll then just have this 2a plus 7 on the right. Now we want the a's on the same side of this equal sign, so it's up to you. You can either move them to the left, or you can put all the a's on the right. I tend to prefer to move them to the left, but always just look at the symbols and see if it's going to create any additional negatives anywhere, or if we can remove negatives by moving to the other side. Now in this case, we have plus symbols on both sides, so it doesn't really matter, so I'm going to minus 2a to the other side. Now we also need to minus 3r. You can do that in one jump if you're happy doing so, but I'm going to move it in 2 steps. So I'm going to do ar minus 2a, and then we have the plus 3r, and that's equal to 7. Now I'm going to minus this 3r, so we have the a's on their own, and that's going to make it ar minus 2a is equal to 7 minus 3r. And of course this would look slightly different if we move the a's to the right. Now at this point we can factorise the left. We can factorise the a out of the bracket, which will leave us with r minus 2 inside the bracket, and then we have that is equal to 7 minus 3r. At this point, the final step is to divide by this bracket. That's going to isolate the a and leave it as a equals, and then as we are dividing by that whole bracket, we need to create a fraction. So we have 7 minus 3r all over, and it's up to you at this point. You can leave it in the bracket or you can remove the bracket, but we have r minus 2, and there we go, and that would be our final answer. A is now the subject, and a does not appear anywhere else within this. So there we go, that is changing the subject with some factorising. Okay, so looking at some algebraic proof, this question says prove algebraically that the difference between the squares of any two consecutive odd numbers is always a multiple of 8. Now, when we are looking at an even number, we will use the algebraic expression 2n. When looking at an odd number, you can either use the positive or negative version of this, but all we need to do is add 1 to the even number. So for the first odd number, we'll have 2n plus 1. The next odd number, we would add 2 to that, thinking about a number line. You add 2 to get between the odd numbers. So the next one would be 2n plus 3. Now it wants you to find the difference between the squares of these. So the squares of them, we would put them in brackets and square them, which is going to mean we've got 2 lots of double brackets to do. But we need to be really careful here because when you are finding the difference between two things, we want to do the bigger take away the smaller. So the 2n plus 3 is the bigger odd number, so we would want to put that first and then put a subtraction between them. So there we go, we want 2n plus 3 squared take away 2n plus 1 squared. So we want to take our time expanding these. So for the 2n plus 3, we would get 4n squared plus, and maybe expand it to the side, but I would like to do it all in one go. 2n times 3 will be 6n. We've got 2 of those, so we would have plus 12n, and then plus 9. If you don't like expanding a double bracket in one step like that, then obviously just write 2 brackets to the side, 2n plus 3, and 2n plus 3, and just take your time to expand them, and just make sure you get that expression correct. We are then going to subtract the next one, and again, you just write out 2n plus 1, and another 2n plus 1, and that gives us 4n squared plus 2n, so plus 4n, and then 1 times 1 gives us 1. Now, because of this subtraction, because we are finding the difference between them, we have another scenario where we need to be really careful, because we're actually taking away all of these. So I'm going to put that into a bracket just so I don't forget that all of those 3 pieces are being subtracted from the first 3. So we have 4n squared, take away 4n squared. Well, actually they just cancel out, so they disappear. We don't need to worry about the n squareds. We then have 12n, take away 4n, so that leaves us with 8n. That's a good sign because it did want us to show that it's always a multiple of 8, and anything times 8 is going to be a multiple of 8. And then we have plus 9 and take away the 1. 9 take away 1 leaves us with 8. So there we go. We're definitely in a good position here. It wanted us to show that something's always a multiple of 8. Now at this point you could actually write a description here which says why that's always a multiple of 8, because if you times any number by 8, it's in the 8 times table, and if you add 8 to that, it's still in the 8 times table. However, a really good process at this point is to factorise by that number that we want to show it's a multiple of. So if we take a factor of 8 out, you get 1n plus 1. And there we go, this 8 on the outside here shows that any number that you put into that bracket, it's always going to be something multiplied by 8, and therefore it's always a multiple of 8. You can write some words along with that if you feel happy to do so, however you can just leave it with this algebraic proof as well. I do like to just add some words and just point at the 8 and just say anything times 8 is always a multiple of 8. Okay, so looking at some linear inequalities. So in part A here, we have to solve a linear inequality, and this particular one does have a fractional coefficient of x there. We have a negative 1/2 x. Now, whenever I'm solving an equation or an inequality, I always look for the smallest coefficient of x. And in this case, the smallest coefficient is a negative coefficient of x, so minus 1/2 x. Now, in order to make sure that we only have an x on one side of an inequality or an equation, we need to do the inverse of that smallest coefficient. So minus 1/2 x, the opposite to that, the inverse, is adding 1/2 x. So we'll add 1/2 x to both sides. Now that does give us, on the left-hand side there, 1.5 x. Now we could write that as 1.5 x, completely up to you, but we have 1.5 x plus 11 is less than or equal to 5. Now that we only have the x's on one side of this inequality symbol, we can get rid of this positive 11, again by doing the inverse. So when we minus 11, we now have 1.5x is less than or equal to, and we can do something like 5 minus 11 on our calculator anyway, but we get -6. Final step is to divide by that coefficient in front of x. In this case, it's 1.5. So we're going to divide by 1.5, and -6 divided by 1.5 is -4. So we get x is less than or equal to -4. This question doesn't say this, but that could also be plotted on a number line. We would have to find -4, we would put our circle above -4, point it in the same direction of the arrow, and because this has the extra ink on our inequality, meaning it can be equal to as well, we have the extra ink inside this circle and we colour it in to symbolise there that it can also be equal to -4. Part B here does ask us to draw a number line. So it says on the number line, show the set of values of x for which, and then we have this joint inequality, and sitting in the middle of that joint inequality, we have a +3. Now, when we are dealing with these, we deal with it exactly like we did just above. So in this step just here, the first thing we did was to -11, and in that case we also did divide by 1.5. Now, we do exactly the same here. So whatever is next to the x, whether it be a coefficient of x or a number being added or subtracted from it, we have to do the inverse. In the case of a joint inequality, we have to do the inverse to both sides. So where I'm going to subtract 3, so it's just x in the middle, I'm not just going to subtract 3 from one side, I'm going to subtract it from both. Now when I do that, -2 take away 3 is -5. We now just have the x in the middle, and 4 take away 3 is 1. This inequality, now it's just x isolated in the middle, can be plotted on our number line. So we draw a circle above -5, a circle above 1, we join them up, and this inequality symbol on the right also had that equal to symbol in the question, which means the one on the right here also needs to be coloured in, just like in that example above. And that is linear inequalities. Okay, so for a simultaneous equation, there are lots of different ways that you can approach this. The way that I approach it is I make the coefficients of y the same number. Not necessarily the same symbol, but just the same number. So here I'm going to look for the lowest common multiple of 6 and 4. So for me that would be 12, so let's times by 2 and times by 3. We'll then have a +12 and a -12. So timesing the top by 2, we get 4x plus 12y is equal to 10. For the bottom one, we get 9x minus 12y is equal to -36. Now the way that I approach these is if these have the same signs, I subtract the equations, otherwise we add them together. So we're going to add these two equations together, and that leaves us with 13x is equal to, and 10 take away 36, because we're adding -36, gives me -26. Now that's good because 13 does go into 26, don't forget it's negative there, so x is equal to -2. And of course you can get decimals in this part of the equation too, and if you have a calculator, of course you can just type that in and get your nice decimal solution. Now we have the value of x, we need to substitute it into one of the equations to find the value of y. Typically, I'll always pick the one that has a plus symbol in, so I'll go for this top one. So we have 2 times -2, which is -4. So our equation is -4 plus 6y is equal to 5. To solve this, we can add 4 to both sides, getting rid of that -4, and that gives us 6y is equal to 9. And now we can divide by 6, and that gives us y is equal to, and I could either write that as 9 over 6, or if I'm not sure, I can just type it into my calculator, and 9 divided by 6 is 1.5. So y is equal to 1.5. So there we go, we get two solutions, one for x and one for y, and that's our simultaneous equation solved. Okay, so looking at solving quadratics using the quadratic formula. Now when you're on a calculator paper, even if a quadratic does factorise, it doesn't mean that we can't use the quadratic formula. So here the first thing we want to do is we want to label the values of a, b and c. So a is 6, b is 5 and c is -6. We can write down the quadratic formula and start typing it into our calculator. So I tend to start by starting with the plus symbol doesn't actually matter, but we'll start with the plus symbol here and putting that b value in brackets. So we have 5 squared here. We're going to take away 4 lots of a, which is 6, and c, which is -6. And then on the bottom we have 2 times a, so 2 times 6 on the bottom. We can press equals and we'll get our first solution here. We can write that down as a fraction, or we can convert it into a decimal. Just be careful, this one is recurring. And then we can start looking at the negative version. So we want to go back into our calculator rather than typing it all in again, and just go all the way back to that plus symbol. We're going to delete the plus symbol, put in that subtraction, and then press equals again. We get our second solution there, which is -3/2. Or of course, you can write that as a decimal. And there we go, that's the quadratic formula. Okay, so in this question we have a quadratic simultaneous equation. We do have quite an extensive one in this particular question. So we're going to use the substitution method, but you can see our second equation there, we have a 3x and a 4y. So we want to rearrange that formula so it's either x equals or y equals, which does mean we're going to have fractions involved in this one. Now, it's better here, I think personally, to make it x equals, and that's purely because we have a 1x squared here, and that's just going to avoid multiplying it by 4 as well once we've sort of squared it and subbed it in, but it doesn't actually matter either way. Now, I'm just going to opt for making it x equals. So I'm going to rearrange this formula to start with, so that we have our x equals formula. So to do that, I need to minus the 4y, so we have 3x will be equal to 7 minus 4y, and then divide by 3, we get x is equal to 7 minus 4y, all divided by 3. I can now substitute that into that first equation. However, it is x squared, so we need to work out what that is squared. So x squared is first going to be equal to 7 minus 4y all over 3 squared. Now that means we're going to have a double bracket on the numerator. The denominator is nice and easy, 3 times 3 is 9, but I do have a double bracket I need to expand. So I need to get that out of the way first, just to avoid huge amounts of working out written over and over again. So if we expand this double bracket, we have 7 times 7, which is 49, 7 times negative 4y, which is minus 28y, we get minus 28y again, and then plus 16y squared. Now if I just reorder that and write it into a normal quadratic format, we have 16y squared minus 56y plus 49. And there we go, there's our numerator. Now on the bottom, 3 times 3 is 9, but we can put that now all into this first equation. So we have 16y squared minus 56y plus 49 all over 9, and then we have minus 4y squared is equal to 9. Now in order to get this equal to 0 and into a format that we are used to, we do need to get rid of this fraction, so I need to times by 9, which will get rid of this divide by 9. I just need to remember as well, this is also multiplied by 9, and so is this number at the end. So I need to multiply everything by 9 essentially. Now when we do that, we have 16y squared minus 56y plus 49. The fraction is now gone. And we have minus 36y squared in place of that 4y squared. And 9 times 9 is equal to 81. Now I want this to equal 0. It now does only have y's in it. I can definitely solve it. I need to minus 81 and I need to combine these y squareds. 16y squared take away 36y squared would give me minus 20y squared. So I've got minus 56y, and I need to do 49 take away 81. Of course, we can just do this on the calculator. That gives me minus 32, and that's now equal to 0, and it can be solved. Now at this point, I can just write down the values of a, b, and c and put it into the quadratic formula. However, I can see that these numbers divide by 4, so just to make the numbers a little bit nicer, I'm going to divide them all by 4, and that gives me minus 5y squared minus 14y. Again, you can just type this in on the calculator, and then minus 8 is equal to 0. I do just have some slightly nicer values of a, b, and c now to use in the quadratic formula. So a is equal to negative 5, b is equal to negative 14, and c is equal to negative 8. I need to remember my quadratic formula, but now I just need to put the values in the correct place, and just being careful as we type them in. And obviously we just looked at the quadratic formula, so we won't pop the calculator up for this one. We have minus b. B is negative, so that'd be 14 plus and minus the square root of. We've got negative 14, so making sure that's in a bracket, squared minus 4 times negative 5 times negative 8. There we go, we'll have to extend our square root there. And that's all over 2a. A is negative 5, so 2 times negative 5. Now I need to type that in once using the plus symbol, and if we type that in for the positive, and I just like to label that the fact that I've used the plus sign. When we use the plus sign, we get y is equal to negative 2. And when I use the negative symbol, so go back into the calculator, delete the plus, put in a minus, we get y is equal to negative either 4/5 or 0.8. I'm going to leave it as a decimal, so y is equal to negative 0.8. So there's our two y values. I now just need to find the x values. Now I've got two that I need to find, and our equation for x is up here. So to get x, it's 7 take away 4y, all divided by 3. Now again, I'm just going to be typing this in the calculator, so we'll start with the negative 2. So we'll have x will be equal to, let's have a look, x is going to equal 7 take away, it's 4y, so 4 times negative 2, all over 3. And in that circumstance there, we get x is equal to 5. And for the next one, we have x is equal to 7 take away 4 lots of negative 0.8. Again, all divided by 3. And that gives us x is equal to either a fraction 17 over 5, you could write it as a mixed number as well, or the decimal is 3.4. So there we go, we have lots of numbers that we need to write down as our solutions. We have y is equal to negative 2, and in that scenario, x was equal to 5. And we also have y is equal to negative 0.8, and in that scenario, x was equal to 3.4. So a very complex quadratic simultaneous equation. Even just looking at all that writing, there is a huge amount there, so it's really important to keep this incredibly neat and tidy and ordered when you are doing this on the page. But there you go, there is a pretty tricky quadratic simultaneous equation. So with identifying types of graphs, there isn't really an approach that you can use to work this out, so to say, but you need to just recognise what these types of graphs actually look like. So question or graph A here, that is an x squared graph. You have a positive and a negative variation of your x squared graph. This one, it makes this U shape. A negative x squared is upside down. It makes this almost N shape. So recognising those is your starting point. You then have to look at your cubic graphs. So cubic graphs are these ones here, where we have this almost wiggle in the graph, and there's another one just there. So both of these are cubic graphs. Now the x cubed graph on its own only has one root. It passes through 0. So this one down here is the x cubed graph. The one in graph B just has some additional things along with the x cubed. But it still starts with x cubed. However, this one that we're given here, y is equal to x cubed, is graph F. Moving on to some other graphs, graph E is a straight line graph. So this would be y equals, and then maybe something like x plus, and then let's just make up a number, something like x plus 3, if the y-intercept here was 3. Of course, you can have a graph that's sloping downwards as well, and that would have a negative x value in terms of its gradient. The only two that are left over are our reciprocal graphs. So we have graph C and graph D. Now the 1 over x is a reciprocal graph. Now when we have part of the curve in this positive quadrant of the graph, that's where it's a positive 1 over x. The other graph, which we have over here, which is also a reciprocal graph, it has it in the negative quadrants of the graph. So this is where we have a negative 1 over x, or something along those lines. So here, this graph here is graph D. Now, as well as those 6 graphs there, You also need to have a recognition for the trigonometric graphs too. But this one here is just looking at your standard quadratic, cubic, reciprocal, and of course, straight line graphs. Okay, so in this question we are looking at a quadratic sequence. Now when we have a quadratic sequence, there are different methods that you can use. I know some people learn a formula for this, but I use the logical approach. So over to here, we're going to have a look what the difference is between these terms. Now in the first instance it's 2, then it's 4, then it's 6, and then it's 8. Which means that there is a second difference to this sequence. The first is 2, and then 2, and then 2. Now, a second difference of 2 is a unique property to the square numbers. If you actually draw out the square numbers, you'll see 1, 4, 9, 16, they have a second difference of 2. We first get 3, then 5, then 7, and then the second difference is 2. So all that finding a second difference of 2 tells us is that it's somehow related to the square numbers. Now, that sequence up there is called n squared, and n squared has a second difference of 2. So whatever you get as your second difference, to find what goes in front of n squared, because it can be 2 or 3n squared, you have to divide the second difference by 2, and that tells us that it's 1n squared. Now 1n squared is the sequence that we've just written out. 1, 4, 9, 16. I'm going to put another one because we have 5 numbers in our sequence, and all we want to do is see, okay, well we know it's related to n squared, but how is it different? How does it differ from the sequence we've been given in the question? Now I tend to write that down as the difference. You can write it down as whatever you like, but to get from 1 to 1, that's a difference of 0. To get from 4 to 3, that's a difference of minus 1. And it's got to be careful when I say difference here, because normally a difference is always a positive value, but here we're just looking how we get from the sequence back to our original. So from 9 to 7, we take away 2, from 16 to 13, we take away 3, and from 25 to 21, we take away 4. Now ideally, we want this difference to be a fixed number. If they were all minus 1 or all minus 2, we could finish this nth term off and just say n squared minus 1 or n squared minus 2. Unfortunately, we have got the hardest version here, and that's where we now need to find the nth term of this sequence here. Now one thing we can do is we know the nth term is starting with n squared, so we can sort of put that in terms of our final answer. But now we need to find the nth term of this sequence. So at this point, it's almost like forgetting about the entire question. Just imagine we had a question that just said, here's a sequence, find the nth term of that sequence. Well, in that scenario, we would again find the difference. In this case, it's minus 1, which means it's minus 1n. And then we find the difference from the negative 1 times table to this sequence here, and that is adding 2. You can go backwards from the 0 as well, if you would prefer. But here, if we do go backwards, or if we think about this, from negative 1 to 0 is adding 1, from negative 2 to 1 is adding 1. So this is plus 1 on the end of our minus 1 times table. So the sequence that we have there is just 1 bigger than the negative 1 times table. That's all that that part means. So this particular sequence is minus 1n plus 1, which of course you can just write as minus n plus 1, or you can leave the 1 in, it's up to you. So it's minus n plus 1, which is being sort of added on or subtracted from this sequence, whichever way you look at it. So there we go, n squared minus n plus 1 is our nth term for this quadratic sequence. Now our next question is looking at a graph transformation. So here it says the turning point on the graph of y equals g of x has coordinates negative 2, 7. Write down the coordinates of the turning point on the graph of y equals g of x minus 5. Now if there is something within the bracket, like a plus 5 or a minus 5, it affects the x coordinate. But when it's in the bracket, just like kind of like when we're solving quadratics, it does the opposite. So we know when you solve a quadratic and you flip the symbol, it's kind of a similar sort of idea to that, in the sense that it does the opposite of what we expect. So instead of taking away 5 from the x coordinate, actually what this does is it adds 5 to the x coordinate. So here the x coordinate is negative 2, so negative 2, add 5, gives us 3. So our new x coordinate would be 3, the y coordinate remains unchanged, so that would be 7. So there we go, just adding 5 to the x coordinate. The next part says the graph of y of f of x is shown on the grid, and we can see the graph on the grid to the right. On the grid, sketch the graph of y equals minus x, f of minus x, plus 4. Now, although we just spoke about how something in the bracket does the opposite, when it's a negative symbol like this, that's just asking us to change the sign on the x-coordinate. So you can't do the opposite of that. The opposite of that would be doing nothing. So here, it does change the sign in front of the x-coordinates. It also then wants us to add 4. Now, there's a couple of different ways you can do this. You can think of these as transformations. So a minus in the x there, which changes the values of the x-coordinates, actually does a reflection in the y-axis. But we can find that just by picking a few points. So we can pick a few here. Let's just pick these 3. Now the top one has an x-coordinate of -2. So that one would form an x-coordinate of +2. So we can kind of do these in 2 steps. So I've got that one there. The -5 would flip over to +5. And the +1 would flip over to the -1. And if there are any other whole number coordinates, we can do the same. There's a couple down here as well. Again, that 2 goes to -2. And the -6 down the bottom left there would go to +6. Now, if it was just minus x, that would be the transformation that would take place. It's done a reflection in the y-axis. And there we go, we'd sketch it in like that. However, this particular one is also asking us to add 4. Now, when there is a number outside of the bracket, it affects the y-coordinates. And thankfully, unlike when it's in the bracket, it does do what we'd expect. So here, that would move it up by 4. Remember, the y-coordinates follow the y-axis. The y-axis goes up and down. So if we move this up by 4, it's going to finish the graph off. So we can move each point individually. So this top point, and I'll go from the top point there at the very top where the turning point is, up by 4. I'll go up to 7. The 2 points that are on the x-axis there will go up to 4, just here. And then the 2 very bottom points that are down at -7 are going to go up to -3, just here. So there we go. Our final curve that we're going to draw in goes up, and this one over this side goes up as well. And just trying to draw it in as best you can. The important part is that you go through those coordinates, and there we go. That would be our final graph. And obviously, if we'd drawn this as a sketch in pencil, just to help us find it, we could get rid of that one. But there's our final one. So it has reflected in the y-axis when the x-coordinates change signs. And then it's also gone up by 4. And there we go, that is a graph transformation. Now this question is looking at perpendicular lines. So here it says find an equation of the line that passes through C and is perpendicular to AB. So if we kind of imagine a line which is perpendicular to AB, doesn't necessarily go through the middle of that line of course, but it might be something like this. So it's perpendicular to AB and it forms a right angle. Now drawing it in can help along the way, but ultimately we need to find out what the gradient of that line is. Now we can find the gradient of the line by looking at the coordinates A and B. Now B over here is the coordinate, and let's just have a think. The x-coordinate is 0, the y-coordinate is 4. A down here, the x-coordinate is -2 and the y-coordinate is 0. So if we want to find the gradient of AB, we can then find the gradient of this perpendicular line. So for the gradient, we will do the change in y divided by the change in x. So here, the y-coordinates go from 0 to 4. So 0 minus 4, or you can do 4 minus 0, and then over the change in x, which is -2, take away 0. So for that, you can also just think about it as a distance as well. You could do the positive versions. From 0 to 4 is 4, from -2 to 0 is 2. So we can actually just use the positives, which probably would have been nicer in this one. But -4 over -2, which is +2. So the gradient of AB is 2. If we want the perpendicular gradient, we have to do the negative reciprocal. So the negative reciprocal, we change the sign in front of that gradient, so it becomes negative as it was +2. And then we do the reciprocal. The reciprocal of 2 is 1 over 2. So our perpendicular gradient for that perpendicular line is -1/2. So we know what our equation is going to look like. It's going to be y equals -1/2 x plus c. We just need to find what that y-intercept is, that value of c. To do that, we need a coordinate that's on that line, and it's told us that this one passes through the point C. So I just need to substitute that value, or those coordinates, into my line equation. So y is -1, that's equal to -1/2 multiplied by x, which is 5, and then plus c. Now in this circumstance here, we would likely just use the calculator just to make sure we get these values correct, but 1/2 times 5 is just 2.5, and it is -1/2 times 5. So that would just become -2.5. You could leave it as a fraction or a decimal, it's completely up to you. I'm going to write it as -2.5 plus c. To get the value of c now, we just need to add 2.5 to both sides of our equation. That will isolate c. We will then have the value of c. So c is equal to, and again you can do this on the calculator, but -1 plus 2.5 is equal to +1.5. Or you could write that as a fraction. If you want, you could leave it as 3/2. So for this one, we now know the value of c. All we're going to do is put this value of c in place of c in the equation that we'd already written. And here we go, we would have y equals -1/2 x plus 3/2. Now you can write those as decimals if you like. You can write -0.5x plus 1.5, but I tend to just leave the equation that I'm writing either as a fraction or as a decimal, but it's completely up to you as to how you write it. But there we go, there was dealing with perpendicular lines. So there are lots of different functions questions, but here are some of the, I'd say, core parts of functions that you definitely need to know. So you need to know how to do a composite function, like we have here in part A, GF with a -3, and an inverse function like we have in part B. And there are lots of different variations of this. You can have an x in the bracket in that composite function as well, where you have to substitute one of the functions into one of the other functions. You can also have a number in the bracket in your inverse function, and lots of different variations too, but I'll link the full video in the description so you can check some of those out. So part A here, we're asked to do GF and then -3. Now when we are doing this, we are going to first substitute this -3 into the letter that's closest to the number. So I've tried to just highlight the F there. So we're going to do F -3, which means to put -3 where the X is in this F function. Now when we do that, we get 2 times -3, this is in the bracket, so 2 times -3, and then add 3. And that whole thing is squared. So we just have a number sort of calculation here to work out. 2 times -3 is -6, add 3 is -3, so it's -3 squared, and that is +9. So when we put -3 into the f function, we get +9. We also have the fact that it was GF -3. So now we put the answer into the g function. So this 9 now just goes where the x is in the g function, meaning we have to do 2 times 9 and then take away 1. 2 times 9 is 18, take away 1 is equal to 17. And there we go, that's our final answer there, looking at a composite function. For part B, we have an inverse function. This is quite a nice one, as our g function is quite a simple one. But the process that I use is to swap g of x for the letter y. The only reason for that is it's easier to do the following step, but you can use your own method if you've learned a different method to this. So I write the function as y equals 2x minus 1. The inverse function means the reverse function. So the reverse function of this is not timesing by 2 and taking away 1, but adding 1 and dividing by 2. And that process is found by making x the subject. So by writing g of x as y, I can make x the subject and I can move pieces around a little bit easier than if I'd left it of g of x. So if we add 1 to both sides, we get y plus 1 is equal to 2x. And then I can divide by 2, giving me y plus 1 divided by 2 is equal to x. Now my inverse function is this one just here. The only thing we have to do is on the dotted line, it will normally say in a question like this, g minus 1 of x equals, and then give you a space to write your function. So we just replace the y back with the x, and we get x plus 1 over 2, and that is the inverse function. Essentially, that is what does the reverse of timesing by 2 and taking away 1. The reverse of that is adding 1 and dividing by 2. And there we go, that is an inverse function. As I said, lots of different types of functions. I'll link the videos in the description though, so that you can check more of those out. So for our next question, we're looking at forming and solving equations. It says here is a parallelogram. Now with a parallelogram, we know that the opposite sides are equal, and also the pairs of opposite angles are equal. So when we're looking at opposite angles, we're looking at sort of these ones here. We also have in a parallelogram, because these are parallel lines, we have co-interior angles. So these two angles here are also equal to 180 degrees, just like the bottom two are as well, basically any two that are next to each other. So that's all of the things that we need to know about a parallelogram. From there, we just need to be good at solving equations. So here we are given two options. We can either make an equation where we say this angle and this angle are equal, or we can make an equation where we say this angle and this angle are equal to 180. However, that option there leaves us with an x and a y in the equation. So we're going to start with these first two that just have x's in. That's going to allow us to form an equation with only x in that we can solve. So for that, we've got 5x minus 20 is equal to 2x plus 43. We can solve that equation. There's x's on both sides, so we have to get rid of the smallest x from both sides. We get 3x minus 20 is equal to 43. We then need to add the 20 to the other side, so 3x is equal to 63. And then dividing by 3, we get x is equal to 21. So we now have the value of x, and that's what it wanted, the value of x, and it wants the value of y. So if I substitute this value of x into this bottom angle is now 4y minus 5 lots of 21, which is 105 degrees. So I now have an equation. I know the size of this angle as well, and I know that they're both going to add up to 180. So let's also substitute the value of x into this one. I could use the bottom one as well, but I'm going to stick with the top one as I've gone for that one now. 2 lots of 21 is 42. So 42 plus 43 is this top right angle, and that is equal to 85. So if this top angle is 85, and the two of them have to add up to 180, well, I can do 180 minus 85, and that leaves me with 95 degrees for that bottom right angle. So 4y minus 105 equals 95. And then I've got a relatively nice equation to solve there, especially considering we're using a calculator at the moment. 4y is equal to 200, and therefore y is equal to 50. And there we go, there is forming and solving equations. Now obviously in that particular question, we had an equation where we had x's on both sides, and we had an equation where we had an unknown on one side down the bottom there when we were solving for y. So all different types of equations, but the important part of this topic is to know your shape and angle facts. So in this one here, we knew that the opposite angles in a parallelogram were equal. As well as that, we knew opposite sides were equal, but we didn't have to deal with sides in this one because we were exclusively looking at the angles. But there we go, there's some forming and solving equations. Okay, so looking at product of primes and highest common factor. Now part A here says to write 156 as a product of its prime factors. Now there is one button you can actually just click on your calculator and it will do the product of prime factors for you. I have got a video which I'll link in the description, which is calculator hacks, where you can type this in. So I'll link that in the description. If you want to see how to do this in one button, then you can do that in that video. Now, if you don't have a calculator that does that, we still need to be able to answer this. So we need to find numbers, and typically, if it's a calculator question, we would expect the number to be a little bit more complicated. So what I can do is I can just do 156 and I can divide it by, and just pick a prime number. So I'll divide it by 2, as I can see it's even, and we get 2 and 78. So I'll circle the prime and I'll just keep going. Now that divides by 2 again, so we'll divide by 2, and it gives me 39. 39 doesn't divide by 2, so let's click divide by 3, and that works. We get 3 and 13, and I actually know 13 is a prime number. If you weren't sure though, because there was a question which came up where 31 was one of the numbers here, and I think a lot of people questioned that and thought, is 31 a prime number? So if you're not sure, just divide by 2, divide by 3, divide by 5, and typically I'd also try dividing by 7. That isn't necessarily going to cover all numbers in existence, but typically testing those 4 numbers is going to be enough that you'll be pretty confident whether it is a prime number or not. So 2 times 2 times 3 times 13, or 2 squared times 3 times 13. Now, when we are finding the highest common factor of numbers like this, you might want to use a prime factor method to find the highest common factor. You might prefer just to find the factors of 130, which won't take you too long to do, and just see if they fit into 156. So for example, 130, we know it's 1 and 130. I can, on my calculator, if I want, just do 130 divided by 2, and there we go, 65. So I can get these answers relatively easily. I can then do 130 divided by 3, that doesn't fit, so I can keep on going. 130 divided by 4 is not going to work there because we can see 65 doesn't halve, but it does divide by 5, so 5 and 26. We can keep going, we should know that it divides by 13, so we know we're going to get 10 and 13. It's just whether any of those numbers in the middle there are also going to divide. So on my calculator, I'll just do 130 divide by 6, that doesn't work. Divide by 7, that doesn't work. And then just testing the last few, and there we go, none of those numbers work. So I'd want to test 11 and 12 as well. I already know that they don't divide. But from here, I would just look at these largest numbers, see if they fit. 130 doesn't. 65 doesn't. I'll have to test 26. That's not one that I would know off the top of my head. And actually, there we go. 26 is the one that fits. Now that's one method of approaching it. The other method that you could use, if you prefer, is to find the prime factors of 130. So 130, which if we were to do that relatively quickly as a product of prime factors, we could go 10 and 13, and then 2 and 5. So it's 2 times 5 times 13. Now once you've got them both written as a product of prime factors, any numbers that are in both, and again we'd want to write this in its long form ideally, above, any prime factors that are in both, so we have a 2 in both, and we have a 13 in both. To find the highest common factor, you just multiply those two numbers together. So we link those up, times them together, and we get 2 times 13, which is 26, which of course we already knew anyway, but there we go. There's 2 different methods that you could use for finding the highest common factor, because you never know if those numbers are going to be quite difficult, and if they are, writing out a list might not be the best method. Of course, the numbers might already be given to you in prime factor form, in which case knowing this method is going to save you a lot of time. Okay, so looking at some further trigonometry, this is one of those types of questions that just involves everything. It says ABC is a triangle, D is a point on AB, work out the area of triangle BCD. Give your answer to 3 significant figures, but we'll deal with that right at the end. So triangle BCD is this triangle here. And let's just think about what we need in order to get the area of that triangle. Well, we've got an angle of 25. If we were to use that angle, and the formula for the area, we're going to be using the area is equal to half AB sine C. So if that angle is our C, we need the A and the B, meaning that we need this length here, let's call it X, and we would need this length here, let's call it Y. Now at the moment, of course, we have neither of those. So we need to have a look at the other triangle and think about how we could possibly get one of those lengths. Now, if we look at this triangle on the left, we have got enough information to find this side opposite the angle. We can use the cosine rule for that. So the cosine rule for a side length is a squared is equal to b squared plus c squared minus 2bc cos a. Now you can rearrange the letters in that formula, but I tend to just use one version of the formula, and I'll call the angle that I'm going to use my large A. Now as it so happens, it's got an A next to it anyway, but that is going to be my big A, and then the X that we're looking for there is going to be my little a. The other two sides are going to be B and C, so there we go, we can just plug these numbers in, and we'll find one of those first two lengths that we need. So if we put those into our formula, and it's completely up to you here, what I like to do is I like to figure out A by doing the square root of everything, and then putting everything in my formula all in one go. Completely up to you, but if you are answering these type of questions, I'd imagine you're quite happy to do that step there. So we would have 4.9 squared, and a kind of, you know, especially if you're sort of following along with me, sort of typing it in as you go, just to make sure that you're happy to type it into your calculator. Although it's not the hardest to type in, particularly after some of the other types of calculator use we've done. The next one would be 3.8 squared. So again, 3.8 squared, and then take away 2 times 4.9 times 3.8 cos 80, and it will open up a bracket, and that angle there goes in your bracket. So typing that into the calculator, we are going to get, I would imagine, quite a large number, and that's absolutely fine. It does say 3 significant figures, but we will write this out in full to start with. So 5.655381673. And there we go, that is that length X. Now for the moment, I'm just going to write 5 point, and let's just write 655. That's going just beyond the 3 significant figures there, writing 4. Just so it's labelled on the diagram. So now we need to figure out how on earth we're going to find side Y, because we still don't have enough information on that triangle on the right. Now we can use either the sine rule or the cosine rule, of course, to find missing side lengths. However, if we look at the easiest route to get there, we now have one other side length. Now ideally, we would like either the angle opposite that, so that we could then use the sine rule. We could pair this up, and if we know that angle, we'll know this angle here, and then we can do pairs of opposites. So it doesn't really matter which angle we find, but we'll be able to use the sine rule if we can get one of those angles. So that's kind of our next problem now. How do we get one of those angles? Well, looking at the triangle on the left again, is there a way we could get maybe this angle here next to the other one within the triangle, next to that letter D, or maybe that top angle? Now we can definitely get that angle there, or the top angle, because we can use the sine rule on this triangle. On this triangle here, we also have pairs of opposites. So if we get rid of some of this working out, we'll swap to a different colour. We have this pair of opposites. The 80 is opposite the 5.655 we've just worked out, and the 4.9 is opposite this angle here. So if we use the sine rule to figure out that angle, we can do angles on a straight line to figure out on the other side, and then we'll be able to use the sine rule in our finishing triangle to find the length of Y. And then of course we've still got to get the area of that triangle. So we have a lot to do. This is a huge question. So let's use the sine rule on this triangle on the left. So the sine rule is A over sine A is equal to B over sine B. And you can write equal to C over sine C as well. We only ever use 2, so I just tend to label them A and B. Now as it just so happens, we have actually labelled the A and B already from the previous working, and that works nicely for this one. So we can actually just stick with that labelling. If the letters were different, we would want to swap them around and sort of relabel it, but as it so happens, this works out quite nicely. So A is our 5.655 number, 5.655 over, and opposite that, our big A is 80, so over sine 80, and that's equal to, B is 4.9, so 4.9 over, and then we don't know the angle. So in this scenario here, where we are looking for an angle, we actually would normally flip the sine rule over, so make sure we have it set up for finding an angle. But we can just flip them over at this point. It doesn't matter, you can either put it all in the first place, or you can flip it over at a later stage. So I'm going to flip it over now. So we have sine 80 over 5.655 is equal to sine x over, and let's just go with the 4.9. There we go, I've labelled that x x. I should probably get rid of the x now because I don't want us to get confused with the side length. Now we're trying to find this angle, so we'll call that x. Now we can rearrange this. To get sine x on its own, we need to multiply both sides by 4.9. And if we multiply both sides by 4.9, we'll have something we can type in our calculator and we will get that angle. So we have 4.9 sine 80, and that is over 5.655. That's equal to sine x. Now we don't want to know what sine x is, and hopefully you are sort of confident with trigonometry in the sense that we need to do the inverse of sine. You can type it all in one go, or you can type in 4.9 sine 80 over 5.655 and then do the inverse sine of your answer. That's how I'm going to do it. So I'm going to type in 4.9 sine of 80, and on the bottom 5.655. And when I type this in, I'm going to type in a few more of the decimals as well, just to make sure it's as accurate as it can be. I've got it written down over on the bottom right, so 7.3 at the end. We'll type that in, and we do get a decimal. It's 0.85 and a few more decimals there. So I want to do the inverse of my answer. I could write it in there if you want. I'm confident I've got the correct answer written in there though. I'm going to do sine minus 1 of my answer, and I do get 58.5689, a few more. I'm not going to round it, I'm just going to keep it as 58.5689. I'm just going to leave it there. It is a 4 afterwards, so technically I am rounding it, but that's going to be enough decimal places there, or significant figures as well. We've got it to 6 significant figures. It wants our answer to 3. I don't want to just sort of overcrowd everything with tons of numbers. There was actually only 2 numbers left, but that is enough for this angle. So I'm going to label that up here. That's 58.5689. You can already start to see, even with a whole page, you would start to get, this is going to start to get a little bit messy. So let's now move into this triangle. We've used the sine rule. We can move on to the angle next to it. So 180, take away my answer. And next to that now, this is 121.43. I'm going to round it to 2 decimal places now, or 5 significant figures, because it is starting to get to a point where there's just numbers everywhere. Now I can do the sine rule again. So if you're already happy with the sine rule, we're now doing the sine rule for lengths. I want to find this length here, which is opposite this 121. I can find the angle in the bottom right because it's angles in a triangle. So I'm going to do 121.43 plus 25, and then take that away from 180. So that leaves me over here with 33 and then it's 5689. Again, I've used the full number every time, so I get 568949. So at this stage, I'm just going to write the full number in so I don't get any rounding errors. And there we go. That angle there is opposite this 5.655. So I'm going to use the sine rule again. I'm going to do that over on the left, so it's quite a distance away from the shape now. I'm going to keep that top right space there for the final step. So using the sine rule, and again we need to label this up. So this time I'm going to call my y A, and my angle big A, and then this 5.655 will become my B, and this will become my big B. And again, just using A over sine A. So we have y over sine of 121.43, and that is equal to the 5.655 over sine of 33.568, or it just round up for my bracket here, so 569. I need to rearrange this, so y is equal to, and then I'm going to have the sine 121 up on the top, so 5.655 sine 121.43 all over sine of 33.569. I can just type that all in one go. That is going to give me my answer. There's a lot to type in. So 5.655 sine 121.43, and on the bottom we have sine of 33.569. If If I press equals now, I have got an answer for that side length, which I have called y. Y is equal to 8.72658752 And again, I have used some rounded figures there, so this might be ever so slightly different if you've been using different rounding to me. Right, so that is the length up here. We now have 8.7265 and a few more decimals. Okay, so I now have all of the information that I need to work out the area of that triangle. If I was to redraw it, which might be helpful at this stage, it might actually not, because we're just sort of creating more writings and more drawings everywhere. We have the angle of 25. We have the side length over here, which is 5.655. And we have the side length on the other side now, which is 8.726 or 8.72, and that 6 would round up. Let's just keep it as 6.5. So I can now use half AB sine C. I can use my area of a triangle formula. This is going to finish the question, thankfully. There's a lot of working out up to this point. So I just need to type into my calculator 1/2 times A. It doesn't matter what order we put A and B in. So we've got 5.655 times 8.7265 times sine of 25, the angle that we're using there. So I need to type all of this in. 0.5 times 5.655 times 8.7265 times sine of 25. And there we go. Now all of that has led to a final answer for me, which has come out as 10.42775 and a few more decimals. I'm not going to worry too much though, because I do need to round this to 3 significant figures. So if I cut it after the 4, I get a final answer, which has come out as 10.4. So all of that, and I've got to a final answer. I'm going to write it down here, 10.4. This was an area, so it is centimetres squared. And there we go. That's the final answer after all of that working. Now you can see there was an awful lot. So it's not necessarily always going to be the case that you're going to have every single part of trigonometry within one question. The only thing we didn't really do there was using the cosine rule for an angle. But there we go, pretty much all of trigonometry within one question. And there you go, there is some further trigonometry. Okay, so if you've ever sat any past papers or practiced any past papers, which I'm sure that you have, you'll recognise questions like this. Lots of words, fractions, ratios, sometimes percentages involved. So we need to go step by step through questions like these. First, read it through, figure out what it's asking you to do, and then just go step by step from the top. So this one just says, Mayer's got 600 balloons, 2/5 of them are inflated. For the inflated balloons, red to blue is 2 to 3, blue to green is 6 to 5. We want to work out the percentage of Mayer's balloons that are inflated red balloons. And it says give your answer to 1 decimal place, so we know our percentage is going to be a point something. So first of all, we can work out this 2/5 of 600 to see how many are inflated. So on my calculator, 600 divided by 5 is 120. So 1/5 is 120, and therefore 2/5 is double that, 240. Now numbers like that are really important. So make sure you underline them, make sure they're nice and clear so you don't get lost along the way. Even if you want to label that and just write, this is the inflated balloons, might just make sure that you keep using the correct numbers along the way. For the inflated balloons, red to blue is 2 to 3 and blue to green is 6 to 5. Now what should stand out straight away when there's 2 ratios is that blue is in both. But blue has a different number in both. In this one it's 3 and in this one it's 6. So what we need to do is find the lowest common multiple of those. And in this case we only need to change the top ratio, because if we times the top ratio by 2, that will become 4 to 6. And now we have the same number representing blue. So as a 3-part ratio, red, blue and green, we have 4 representing red, which we've just changed, 6 representing blue, which is now the same in both, and 5 representing green. So for these inflated balloons, we know that they are in the ratio 4, 6, 5, which is a total of 15. So we can find out how many of each colour there are. So like we would do with any normal ratio, we'll divide the total by the amount of parts. So 240 divided by 15, just doing that on my calculator, which is 16 per part. So I can multiply all of these numbers by 16. So 16 times 4, and that is 64. We have 6 times the 16 as well, 96 blue, and 5 times 16, which is 80. Now I might not actually need all of them, and in this question I actually don't. It says work out the percentage that are inflated red balloons. So I only really care about these 64 red balloons. Now we have 64 inflated red balloons, but what it's asking me to make it a percentage of is really important. Here it says work out the percentage of Mayer's balloons. Now it could have phrased that in two different ways. It could have said the percentage of Mayer's inflated balloons, which would have been out of 240, because we have 240 inflated balloons. This one though, it says Mayer's balloons. Well, she has 600 balloons. So as a fraction of that 600, we have 64 out of 600 that are inflated red balloons. If we type that in on the calculator, 64 over 600, we get a decimal, 0.106 recurring. To turn that to a percentage, we just times by 100. So times by 100, and our percentage is 10.6 recurring percent. Now it wants this to one decimal place. Typically, if you click your calculator, it'll turn this recurring dot into lots of sixes there anyway, but we want to chop it to, or round it to, one decimal place, which will give us 10.7, because after the 6 is, of course, another 6. So 10.7%, and that would be our final answer. There are 10.7% of Mayer's balloons, which are red inflated balloons. So there we go, working through that question step by step. We had fractions, we had ratios, and we had some percentages there at the end. Okay, and looking at some 3D trigonometry. Now we've looked at quite a lot of the further trigonometry, which can be involved within 3D trigonometry as well, but this one here is a relatively nice one within a cuboid. It gives us some lengths and an angle in the question, so we want to label that on before we start going ahead with everything. We have 7.3, that's this back length here, which is the same as the front. It might actually be easier if we write that on the front, so it's just out of the way a little bit, so 7.3. C to H, which is going up the side, is 8.1, and angle B to C to A is 48. Now if I go from B to C to A, which isn't the nicest one to draw, there we go, it creates this angle here, so that is my 48. It says find the size of the angle between AH and the plane ABCD. Now the plane is the flat surface on the base. So between AH, A to H goes up to here, and the plane, and we've already drawn that line in, and that's this angle here, sort of in the space inside the shape. So that's what we're trying to find, this angle. We'll call it X for now. Now if we look, that creates a right angled triangle within the shape. And if I was kind of to draw that to the side, we have a right angled triangle. We have the length of the height, well, the height of it, the length of this height here, 8.1. We don't have the base, but we have the 8.1, and we're looking for that angle. So if we can find the length of the base, well, we can use SOHCAHTOA and we can work out the angle. So there must be a way of working out that length. Now, if we look at the sort of base of the shape, this rectangle, and we were to draw that out, we don't know exactly the scale of it because we don't know all of the lengths here, but let's go with the 7.3 just here, and we'll split it up, and this here is 48 degrees. This is also 7.3 on the top. Could we work out this missing length in the middle? Of course, that is the base of this triangle. And the answer is yes. We have a right angled triangle there. So we can use SOHCAHTOA. We have the opposite side, and this is the hypotenuse, as that's the right angle in the corner. So that is my SOH formula. So we're going to use sine to work out that length, and we are working out the hypotenuse. So we would cover up the h, or rearrange your formula, whichever way you're doing this. So O divided by S would be 7.3 divided by sine 48. And there we go, we can type that into the calculator. That is 7.3 over sine 48, and that comes out as 9.82. So that 9.82 that we've just worked out, we could put a few more decimals with it if you would like. We want it to one decimal place, so let's do a few decimal places. That length there, being the diagonal from A to C, is also now the base of the triangle that we're looking at in the middle. So that here is 9.8231. And now I can do SOHCAHTOA all over again. So opposite this angle is the opposite. We don't have the hypotenuse, but we do have the adjacent. So this time we will use our tan formula. Whether you use it as a formula or whether you use a formula triangle, absolutely fine. When we're looking for the angle, we need to do the inverse of tan. So we're going to do tan minus 1, and then it's the O over the A. So 8.1 over 9.8231, and then we need to just type that into our calculator. So tan minus 1 of 8.1 over, and just make sure you do type this in correctly. It's a lot of working out to do if you then type an incorrect number in, 231, and that equals 39.508. A few more decimals, but I'm going to stop there because it did only want my answer to one decimal place, so we can cut it after the 5. It's a 0 afterwards, so that comes out as 39.5. Remembering this was an angle, so 39.5 degrees, and that is using SOHCAHTOA in some 3D trigonometry. Of course, not forgetting, you can have to do further trigonometry within SOHCAHTOA, but there we go. There was a nice, or a relatively nice question that only involved right-angled triangles. Okay, so looking at some bearings and trigonometry. This is our last question looking at trigonometry now. So here we've got lots of information, but it says it wants us to find the bearing of Chorlton from Acton. So if we join those two together, Chorlton and Acton, the bearing is all the way around this distance here. So we need to find this angle. If we find that angle, we can add that to the 37, we'll get our final answer. Now at the moment, we don't have a huge amount of information in order to get that. We'll probably be able to use the sine rule at some point, but we need to think about these parallel lines that we have with our north lines. Now the first one that stands out is that we have a co-interior angle just here. So to work out this angle at the top, we could do 180 take away 37, which tells us that is 143. We now have angles around a point, and we can figure out this angle here, which is 67. Now using that information, and let's get rid of this arrow just here and our highlighting now, we can actually find the length of the line that we've drawn in. So to get this line here, we can use the cosine rule. So we'll call this our little a, and this our big A. And the other two sides on that triangle there are our B and C. So for A, it's the square root of, and you can write A squared equals, and then do the square root if you prefer, but it's B squared plus C squared minus 2BC cos A. So the value of A will be the square root of, and we have 8 squared plus 9 squared minus 2 times 8 times 9 cos, and then we have 67. So if we type that into our calculator, the square root of 8 squared plus 9 squared minus 2 times 8 times 9 cos of 67, we get A is equal to 9.4199. And that's our length down here, so 9.4199. Now we can actually use the sine rule. as we have a pair of opposites just there that we now have labelled, and this is another pair of opposites here. When using the sine rule for an angle, we do want to use our flipped version of the sine rule. So we're going to use, and we'll do this in the bottom left, sine A over little a is equal to sine B over little b. So let's call our angle here B and the opposite side little b. So we have sine of 67 over 9.4199 is equal to sine x, the angle that we're looking for, over 9. We can rearrange this now by multiplying the 9 to the other side. So we get 9 sine 67 over 9.4199 is equal to sine x. Now we can type that into our calculator and then we'll do the inverse of the answer. Or you can type it all in one go, completely up to you. I'm going to press sine -1 and I'm going to put the fraction into my calculator straight from there. So 9 sine 67 on the top, 9.4199 on the bottom. And there we go, our final angle there is 61.578 and a few more decimals. Now this question wants our answer to 1 decimal place, so we're going to need to round it anyway. But I need to add this angle, the 61.578, onto my 37. Now I may as well round this number, and that's 61.6, as it wants it to 1 decimal place. So if we add that to the 37, let's have a look. So 37 plus the 61.6, that gives us a total of 98.6 degrees. Now we want to write that as a bearing as well. So the third digit needs to be before the decimal place. So we have 0, 9, 8. There's our 3 digits. And then we have a 0.6 as well. So there's our final answer, 0.9 or 0.98.6 degrees. And that is our bearing of Chorlton from Acton. Okay, so looking at a frequency polygon. Now a frequency polygon, we need to plot on the midpoints of our groups. So between 0 and 10 is 5, 10 to 20 is 15, 20 to 30 is 25, and then we have 35 in our last one. We just need to plot these at the correct heights for the frequency. So from 5, we need to go up to 14, which is just here. From 15, we need to go up to 18. From 25, we need to go up to 26. And then from 35, we need to go up to 12. So up to 12, and there we go. Now a frequency polygon is just joined dot to dot with straight lines. So we're going to join each point. We would use a ruler for this, and just making nice straight lines between those 2 points. And there we go, that's your frequency polygon. Okay, so looking at a quadratic graph. Now this is another topic where there's a really nice calculator hack that you can use by using table mode on your calculator. I'll link the video in the description because there's some really good calculator hacks in that video where you can basically just type this equation in and it does the whole table for you. Now, if you don't have that type of calculator, or you just don't really want to use that method because we need to know how to substitute into this anyway, then I'm going to follow that method. So here we have x squared minus x minus 6. I always start with a positive number when I'm not using table mode. So for this one here, we're going to do 3 squared minus 3 minus 6, replacing the x with my x value, and then just typing it into the calculator. That one there gives me 0. So that's 9, take away 3, take away 6, which is 9 minus 9. Now I need to work my way through and just do all of those using that method, but of course in the next one, substituting 2 in its place, and I get minus 4. For the next one, 1 squared minus 1 minus 6, that gives me minus 6. Now what you can do to save a bit of time when you use this method is try and spot a pattern. Now I've just spotted side by side, we have 2 negative 6s, which means we have this outwards pattern going from the centre. That's going to be where our sort of turning point is down the bottom, that reflection line down the middle. So on the left of this, we're going to have minus 4, like we do on the right there. To the left of that, we're going to have 0, and you can see that sort of outwards pattern going from in between the negative 6's. So it says in part B, draw this graph. So we need to plot it on very carefully. Now watching me plot points is never the most fun, but I'm going to try and plot them as fast as I can. -2, 0, -1, -4, 0, -6, another -6, another -4, and another 0. Now a quadratic graph needs to be joined up with a nice smooth curve. So as best as you can, just making sure that they are not straight lines. This method can be applied to all the different graphs as well. So if you're drawing a reciprocal or if you're drawing a cubic, you can use table mode to find those points, but it's just substituting the x values in and drawing it with a nice smooth curve. Part C here says to use the graph to find, this word's important, estimates of the solution to the equation, and then we're given the equation, but it says equals -2. Had it said equals 0, we'd be looking at the coordinates where it crosses through the x-axis, but this has said -2, so essentially we are dropping the x-axis down by 2 and looking at the solutions where it crosses through this line. Now that's where estimates is important, because obviously all of our graphs are going to be slightly different depending on how we draw our curve, and also we're not computers, so we need to just read these as best as we can. So I'm not going to stress too much about whether it's, let's just find this number. I'm going to go for the one on the right. Now that one there looks like 2.5 to me, but that's, my line's drawn quite thick. Maybe it's 2.4, maybe it's 2.6, but mine is joined up at 2.5. So I'm going to say 2.5. I'm not going to stress too much over it. I've done it as accurately as I can, and I'm going to stick to that number. So -1 and -2 over there, it looks like just past halfway, so maybe -1.6. And there's my two answers. So my two answers would be -1.6 and 2.5. And it's normally quite a strange question when it asks this, because it gives you one dotted line, but you've got two answers. And it seems a bit weird writing down two numbers. So just sticking down the word "and" in the middle of it is absolutely fine. We do have estimates written here, which gives you a little bit of a hint that there's more than one answer. So there we go. -1.6 and 2.5 would be my two estimates for the solutions here, where we're looking through -2 rather than at 0. Now with grouped frequency, we could be asked multiple different things to work out. This particular one is asking us for the modal class interval. Now modal is just another word for the mode, which is the most common. So we want to have a look at the number of adults in this question, and it's about their foot length, and see where the most are. Now the most are in this category here, so we would just write down the category 22 to 24. And there we go, that's our modal class interval. It then says as well to calculate the mean. Now when we are working out the mean, we always just multiply across the rows, get the totals, and then divide by how many there are. And in this case, there are 40 adults. But with group frequency, we have to use the midpoints, and that's why we are only finding an estimate. We don't actually know the size of people's feet in these particular categories, but we use an estimate to get an estimated total. So we'll write down all of the midpoints. Remembering you can add the start and the end of the category and divide your answer by 2, and that will also give you that midpoint. So just typing these in on a calculator, 17 times 3 is 51, 19 times 6 is 114, 21 times 10 is 210, 12 times 23 is 276, and 9 times 25 is 225. Now we just need to add all of those together, so add them all up really carefully on your calculator. You don't want to miss a number or type it in too quickly. We get a total of 876. Now we were told that there was 40 adults. If not, we could find them there anyway. So we just need to divide our answer by 40, and that's going to give us our estimated mean, and that comes out as 21.9. Now always check your answer, make sure it makes sense. 21.9 falls into our range of data here that goes from 16 to 26, and 21.9 would fall into this category here, which is close to the middle. In fact, that category is actually in the middle. So there we go, 21.9 is our mean. Now with sampling and bias, it's a relatively nice topic. We're just looking at proportion. It says here that Sam takes a sample of 50 people. It says that there are 700 people in a fitness club. How many sports bags should Sam order? Well, here he had 17 people that wanted the sports bag, and that was 17 out of 50. So if we're looking at 700 people, we just need to work out that fraction of 700. So you could divide by 50 and times by 17, just doing a fraction of an amount. Of course, you could always look at this as a fraction out of 700 as well and make an equivalent fraction. Now 700 divided by 50 on the calculator tells us that we need to multiply by 14 to make that equivalent fraction. So if we do the same to the top as well, 14 times 17 is 238. So there we go, our answer would be 238. Now this question says to write down any assumptions you made and explain how this could affect your answer. So in this type of question, we are assuming that the sample represents the rest of the people. If the sample does not represent the rest of the people, then our answer could be bigger or smaller. And notice how I emphasised the fact that I mentioned my answer. So this is specifically asking you, how does it affect your answer? So we assume the sample represents the rest of the people. If not, our answer would be bigger or smaller. And there we go, that's sampling and bias. Okay, so looking at a stem and leaf diagram with a box plot. Now for a box plot, it's quite nice to plot the lowest and the highest value. And we can see that in the stem and leaf. We have this number here, and also this one just here. Look at the key to make sure that you know what those numbers represent. The smallest number there representing 173. So that's just here. Check the scale on your box plot just to make sure that each square is 1. If not, obviously just be careful when you're plotting that. 219 is just before the 220, and there we go, that's our smallest and largest value. Now to find the median and quartiles, particularly when we have all of those three to find, I would take a statistical approach for 23 flowers here, rather than crossing all the numbers off and having to then find the quartiles inside all the crossed off numbers. So here, 23, add 1, divide it by 2, that tells you where the middle is. So that's 24 divided by 2, that's the 12th number. So I just need to count along, and I'll underline them so you can see my counting. 6, 7, 8, 9, 10, 11, 12, and there is the middle, 197. So going down from 197, that draws our median. You might want to label these. I'm just going to label it as the median, 197. I then want to find the lower quartile and the upper quartile. I'm going to label them both here just so I don't forget them as I'm doing them, just in case I need to check them. And then to find the quartiles, we do the same as what we did for the median, add 1, but for a quarter, we divide by 4, and we get the answer 6. So we're looking at the 6th number, so that's 1, 2, 3, 4, 5, 6 from the start. There's our lower quartile, and that is 188. And then 1, 2, 3, 4, 5, 6 from the end, and there's our upper quartile, and that's 209. So plotting those on, we have 188, which is 2 before 190, and we have the 209, which is 1 before 210, and then there we go, we can join this together, and that's what our box plot looks like. And there we go, there is drawing a box plot and using a stem and leaf to find different averages. Okay, so looking at a reverse mean, also sometimes called a combined mean, because we're looking at the mean of more than one thing. So it says here there are 25 girls and 15 boys in a class. The mean score for all 40 is 68. The mean score for the 15 boys is 74. Work out the mean score of the 25 girls. Now, again, with a question like this, think about if we had the information, what do we actually need to work out the mean score of the 25 girls? We need their total score, and we would then divide it by 25. So we are missing their total. So what we can do is we can use the mean given to us for the whole class and for the boys to work out their totals, and the girls' total will be what's left over. So 40 students that have a mean of 68, we would have taken their total, let's call it x, we would have divided by 40, and we'd have got 68. So in order to work out their total, we just need to multiply 68 by 40. So 68 times 40, I'm going to type that in on the calculator, gives me a total of 2,720, and that's for all of them. So you can either label that with whatever writing you want, but just remember that is an important number there. That's the total of everybody. I can now apply the exact same to the boys. Now I'm going to write a different letter down because I don't want to get confused with the fact that this is now a different number. So we have y divided by 15 boys gives me a total of 74. Same process, I'm just going to divide times by whatever I would have divided by to get that mean. So times by 15, and we get the total 74 times 15 for the boys, and that is 1,110, and I can label that boys. So for this now, in order to get the total for the girls, I would want to take the total for the whole class, 2,720, subtract 1,110. Don't actually need to do that using column subtraction, but I want to make sure my working out is nice and clear, particularly just in case I have made a mistake. I'm still going to get those method marks for doing the correct process. So the total score for the girls is 1,610. And it even tells us in the last line here, there are 25 girls. So I want to divide that by 25. I'm going to do that on the calculator, and it will give me their mean, which does come out as a decimal, which is 64.4, and that is the mean score for the girls. So there we go, that was a reverse mean, also sometimes called a combined mean, where we're looking at different means that are given to us in one question. Now for cumulative frequency, when we are plotting a cumulative frequency graph, we need to remember that we plot on the endpoints. You also need to check to see, is this the cumulative frequency or is it the frequency? If it's the frequency, you have to add up going down the rows there, just to make sure you get the cumulative total. As an example, if this wasn't the cumulative frequency, you've got 10 in the first, 26 in the next, so that'd be a total of 36. However, this is the cumulative frequency that's given to us, so we don't need to worry about that aspect. We just need to actually draw the curve. So I'm going to plot from 30 up to a cumulative frequency of 10, and that is just here. I then go up in tens, so 40, 50, 60, 70, plotting on those numbers. So 26 is the next one, just here. 50 goes up to 58, and that is just there. Then we have 66, which is just here, and our final 70 goes up to 70, which is right at the top of the graph there. Now there's one more point that we actually have to plot, and that is the starting number. So we have to plot this starting on 20 down at 0 there, not just to the origin. So this is a good example of a question where you have to think about that starting point. Now a cumulative frequency graph, we do join up with a nice smooth curve. So we want to freehand sketch this one in, drawing it nice and smooth, and there we go, that is our cumulative frequency graph. Now it says here to use the graph to find an estimate for the median. So the median, we want to look at how many people there are in total, and there were 70. So if we divide that by 2, we know the median is going to be at 35. So we need to find 35 on my graph, which is just here, and it does say estimate, so we don't need to worry about adding 1 and halving or anything like that when we're doing estimates. So we just need to go across with a ruler, connect it to the curve, and then whatever we're on there, we're going to go down to the other point on the x-axis, and that comes out as 1, 2, 3, so that is 43. So my median comes out as 43, and there we go, there is the median. It also says here, Freya says more than 60% of the people in the office are between 35 and 55 years old. Use your graph to determine if Freya is correct. Now this is a little bit of a pain because we do have to draw lots of lines on the diagram now to find this. So I'm going to go up from 35 and 55. I'm going to find out how many people that is. So if I go across from there, again being really accurate here, there we go, that is 16. And then I'm also going to go up from 55, again trying to draw this as accurately as I can, but you want to make sure you use a ruler and a pencil for going across on these. And there we go, there's our next one, and that is 62. So if we have a look, well, 62 take away 16 is the amount of people in that section. So 62 take away 16 is 46 people. Now, we want to compare that to the 60% because she says more than 60%. So if we work out 60% of 70, there we go, 60% of 70, and whatever method you prefer for that, I'm going to do 70. I'm just going to divide by 100, which gets me 1%, and times by 60, and that gets me 42 people. Well, 60% is 42 people, and we have 46 people. So no, Freya is going to be correct actually, because more than 60% of the people are between 35 and 55. So we would say yes, because 60% of the people is 42. We have 46 people. So use your graph to determine if Freya is correct. So yes, Freya is correct. There we go, and we have our working out to back that up. More than 60% are between 35 and 55. Okay, so looking at some compound interest. This question here says Charlie invests X pounds in better investments for 3 years and Sadia invests X pounds in Country Bank for 3 years. Now, as they both have an X with them, that means they've both invested the same amount of money. It says at the end of 3 years, the value of Charlie's investment is £344,605. Work out the value of Sadia's investment at the end of 3 years. So we need to know how much they invested, and that's what we're going to use Charlie's final amount to figure out. Once we've got that, we'll work out what Sadia gets. Now this is some reverse compound interest, so we need to reverse this process. So we need to know exactly what calculation we would have typed in for Charlie in better investments if we knew his starting amount. Well, we'll call his starting amount X, so we would take his starting amount, X, and we would have multiplied that by 1 point, and then whatever this is as a decimal, so 2.5% is 0.025, so 1.025, and he's invested that for 3 years. And as a result, we got the answer, 344,605. So to figure out what that starting amount was, we just need to divide both sides by 1.025 cubed, and we'll divide this answer here by 1.025 cubed. There we go, that's going to tell us his starting amount. So let's type that in, 344,605 divided by 1.025 cubed, and that comes out as a starting amount, 320,000. There we go, and that is the value of X. So the starting amount is 320,000. So that's what Sadia has at the start. We've now worked this out, £320,000. So now Sadia invests into Country Bank. She gets 2% for the first 2 years and then 3.5% for each extra year. So we're going to first work out how much she gets for that 2%. So 320,000 multiplied by 1 point. 2% is 0.02, so 1.02. And we're going to do to the power of 2 there because it's for 2 years. And then we'll deal with the 3.5%, which is 0.035. So we'll start by working that out. 320,000 times 1.02 to the power of 2. And that gives us a total of £332,928. So that's what Sadia has after 2 years. So we're going to do 332,928 times 1.035 this time for the 3.5%. We don't need to put a power with that because this is the 3rd year. So I can just press times 1.035 and I get my final answer, which is £344,580.48. And there we go, that's our final answer. At the end of 3 years, Sadia would have £344,580.48. And there we go, that's our final answer. Now, there's another compound interest question here. As this reverse compound interest is one just to be careful of, but this question here does have 5 years, and we're trying to work out the percentage. So it says here Natasha invests £6,000 for 5 years. The investment gets compound interest of X% per annum, and at the end of 5 years, the investment is worth £8,029.35. So this time we're working out the percentage. So it's different to the previous, even though they are both reverse compound interest questions. Now, if we knew the percentage, we would do 6,000 multiplied by, and it's a bit of a strange one because we don't know the number there, but it would be 1 point, usually O something, okay, because it's normally a single digit. So we don't know what it is, and that's what we're going to need to figure out. So for the moment, let's just call that multiplier the letter X, as that's what it's told us is a percentage. It's going to be to the power of 5, because there's 5 years, and we're going to get the answer £8,029.35. So this isn't too bad to do, because at this point we just need to divide both sides by 6,000 so that we'll know what x to the power of 5 is. It's more the multiplier at the end we're going to be really careful of. So that would leave us with x to the power of 5 is equal to, and we have £8,029.35 divided by 6,000, and that comes out as 1.338225, but this is x to the power of 5. So we need to do the fifth root of this number. So just like when you reverse a square root or a cube root, here we just need to do a fifth root. And there is a button on most calculators which is a square root button with like a little square next to it. So mine is behind a button that has an X with a little square on it. So I have to press Shift to get that button, and then I can put a 5 in the root box and then type in 1.338225, press equals, and I get X is equal to 1.05, and then lots of 9s. There's 4 9s there, 1, 2, 3, 4, 5 9s, 0, 8. Now, because this amount of money in the question was likely rounded to the nearest penny, it has changed this ever so slightly. So you can see the most likely thing is that this is 1.06. All those 9s there, it's so close to 6, and that's just probably because the amount of money has been rounded to the nearest penny. So here, the multiplier that would have been used would have been 1.06. So up here, where we were thinking about, well, what would this number have been? Well, if the number there is a 6, that would relate to 6%. And there we go. And that's the exact answer that we would get. So the value of x, the actual percentage, is 6%. That's what would go in the multiplier there if we were using 6%. And there we go. That is some reverse compound interest. Okay, so in this question, we're going to be having a look at exchange rates, but also some unit conversions as well. So it says here, in London, 1 litre of petrol costs 108.9 pence. In New York, 1 US gallon of petrol costs $2.83. It then gives us the conversion from gallons to litres and the conversion from pounds to dollars. It says in which city is the petrol better value for money. Now, in this type of situation, we need both of these to be in the same units and in the same currency. So I'm going to start by converting the currency and having a look at in London. So here it's given to us in pence, but we want that in pounds. So that's £1 and 8p, but also has the 9 after it there. So we have £1 and 8 with a little bit after. There we go, put a decimal of a penny. So if we want that in pounds, then we'll leave that as it is. And it's already told us that that is 1 litre. Now that's ideal. So 1 litre is £1 and 8 with that little 9 after it. If it was higher than that, if it told us something like 5 litres, then of course we could divide that by 5 or whatever it was to get down to 1 litre. But this has already given us 1 litre, which is ideal. So the second one has given it to us in dollars. So we want to convert this into pounds. Now you can see in our exchange rate here, the dollar number is bigger than the pound number. So we need to divide by 1.46 to turn this into pounds. We're just going to do that on the calculator. So 2.83 divided by 1.46. And that comes out as, and it's a very, very long decimal, but we have 1.938356164, and the 3 and the 4 have a recurring pattern. There we go, so all the way from the 3 to the 4 is recurring. So we're not going to need to worry too much because we are only comparing the value, so we just want to know which is better value. Now also, we've been told that this is 1 gallon. So if we want to turn that into litres, well, we've been told here that 1 gallon is 3.785 litres. Now we want to compare this as 1 litre. So we have 3.785 litres, which is equal to this £1.93 with the 8356164 number, which I am just going to leave on my calculator because that's really awkward to have to type back in. Now I want to know the value, not for 3.785 litres, but I want to know the value of 1 litre. So to get there, I just need to divide by 3.785, and that's going to tell me the value of 1 litre. I'll just do the same to the other side as well. So if we do that, we have the big long decimal there divided by 3.785, and that comes out as 0.512115235. Now ultimately we don't need to write all those decimals because it was £1.08 in London, and in New York it's only, and if we round it, 51 pence. So in terms of where it's better value, we would say New York is better value. I won't write down all the words there. We'll just say New York is better value, and obviously we have our working out that shows that 1 litre in London is £1.08 and 1 litre in New York is 51 pence. And there we go, there's looking at some exchange rates and some unit conversions. Now this next question is looking at pressure, and we are given the pressure is equal to force divided by area formula. It says a box in the shape of a cuboid is placed on a horizontal floor. It doesn't give us a picture of that, but we can sort of imagine what that looks like. We have a cuboid, there we go, and that is on a horizontal floor, and there is our cuboid. It says the box exerts a force of 180 newtons on the floor. The box exerts a pressure of 187.5 newtons per metre squared on the floor. The face in contact with the floor is a rectangle of length 1.2, let's label that, and width of x. So we don't know what the width is. Work out the value of x. Now, if we can figure out what the area of that rectangle is, then we can figure out the missing length. So let's have a look at what we've got. Now, we have the pressure at the start of our formula, and we've been told the pressure is 187.5. So that is equal to the force, which is 180, divided by the area. So we'll put the area just below. So we need to figure out what number we have to divide into 180 to get 187.5. Now, when we have things like this, these can just be switched over. Now, there is a process to that. You multiply the area to the other side. Let's call the area A, and then you would divide 187.5 back to the other side. But you can get away with this quite quickly just by switching them. So A is equal to 180 divided by 187.5. So if we type that into our calculator, 180 divided by 187.5, that comes out as 0.96. There we go. So 0.96 is the area, and it's in metres, so that's metre squared. So the area of the base of this rectangle here is 0.96 metres squared. We want to know the width. Well, length times width is the area for a rectangle, so 1.2 multiplied by x is equal to 0.96. To find the value of 1x, which is what we want to know, we just need to divide by 1.2. So divide both sides by 1.2, and we will have our width, and that comes out as 0.8. And there we go, that is the width of the rectangle, 0.8 metres. And there we go, there is some reverse pressure to find the area. So moving on to some speed, distance and time. It says here Jessica runs for 15 minutes at an average speed of 6 miles per hour. She then runs for 40 minutes at an average speed of 9 miles per hour. It takes Amy 45 minutes to run the same total distance that Jessica runs. Work out Amy's average speed. Now it's completely up to you what method you use here. You can use a non-calculator method, or we can use a calculator method. As we have a calculator, we'll use a calculator method here, but you can always check out the non-calculator methods, which I'll link in the description as well. So we have speed, distance and time, and we have in each scenario here a speed and a time. So we can work out a distance. So if we want to work out distance, we just do speed multiplied by time. The only thing we need to be careful of is that we write both of these in hours, which is just writing them as a fraction over 60, so 15 over 60, which is 1/4 of an hour, and 40 is 40 over 60. So you don't need to simplify those, you can just leave them as fractions out of 60. That's going to make it easier for us. So in the first part of this, Jessica runs for 15 minutes at an average speed of 6. So 6 multiplied by the time, which is 15 over 60. There we go, and that's going to give us her distance for that first part, and we'll just type that into the calculator, 15 over 60. and that comes out as 1.5. So she runs 1.5, we were looking at miles, so I'll write miles with that, so I recognise that it's a distance. Now in the second part, she runs for 40 minutes, an average speed of 9 miles an hour. So that's 9 as the speed, times 40 over 60, and again we'll just type that into the calculator, times 40 over 60, and that comes out as 6 miles. So in total, she has run 7.5 miles. Now it says here, if Amy takes 45 minutes to run the same total distance that Jessica runs, work out Amy's average speed. So we need to do a formula again, because this time we are working out speed. So speed, distance and time, we are working out a speed, so we need to do distance divided by time. Again, we have 45 minutes, which is 45 out of 60, if we write that in hours again. And then we can use that formula to get our final answer. So the distance we already know is 7.5, and we need to divide that by the time, which is 45 over 60. And if we type that into our calculator, 7.5 divided by 45 over 60, that gives us a final answer of 10. So it says here, work out Amy's average speed. Well, she is going 10 miles per hour. And there we go, it wanted us to give our answer in miles per hour, and the reason that we were converting everything into fractions there was because it wanted the answer in miles per hour. So there we go, we've got our answer in miles per hour, and there is our speed, distance and time question. Now, when we have density, mass and volume mixtures, I like to lay it out in a particular way. But it says here the density of ethanol is 1.09, the density of propylene is 0.97, and then it says 60 litres of ethanol are mixed with 128 litres of propylene to make 188 litres of antifreeze. Work out the density of the antifreeze. Now the formula for density is that density is equal to mass divided by volume, and again we can use a formula triangle. So here we have lots of information. We've got lots of things getting mixed together. When we have this scenario, I like to draw it in a two-way table, just to keep everything really organised and clear as to what we have and what we're looking for. So we'll have a density, a mass and a volume for each thing. We have the ethanol, we have the propylene, and then we have the antifreeze. And there we go, I'm going to write the antifreeze there. And let's see what we've got. We have the density of ethanol, 1.09. We have the density of propylene, 0.97. We can't add those together because we don't know the exact ratios that are being mixed, so that's what we're going to kind of work out. We have a volume given to us, that's what the litres are, and sometimes litres will be given to us in centimetres cubed. But here we have a litre being 60 litres for the ethanol and 128 litres for the propylene, and in total that makes 188 litres. So there we go. Overall, that is all the information that we have been given. Now we want to actually work out the mass of each. So here we have a mass that we can work out. We just need to cover up the mass and do density times volume. Now you'll notice in this question that part of it is in centimetres cubed and part of it is in litres. Now it's fine for us to keep the answers in litres here because we're going to keep it all in proportion, and as long as we keep all of our numbers the same, well actually once we come to work out the density anyway, it's going to stay in that same proportion. So it's absolutely fine for us to leave this in litres and not worry about the fact that those are different units, but quite a unique scenario in this question. For working out the mass though, we are going to do this multiplication, so I'm going to write my working out to the side for this first one, which is 60 multiplied by 1.09. So 60 times 1.09, there we go, and that comes out as, when we multiply them together, 65.4. So that is 65.4. I can then work out the mass of the propylene, just here, by doing the volume, 128 times 0.97. So 128 times 0.97, there we go, and that's going to give me the mass of the propylene, and that comes out as 124.4 0.16. Now we can add the masses together. If they're being combined, then their overall mass is just adding them together. So our total mass is 189.56. And then again, looking at our density formula, density is equal to mass divided by volume. So to find the density, we'll do the mass divided by the volume, and that's going to finish this off, which is 189.56 divided by the 188. We'll just type that in on the calculator, and that gives us a final answer here, which comes out as 1.00829. There's a lot of decimals here, but it does want my answer to 2 decimal places. So if we chop it after the 0, that is going to round to 2 decimal places as 1.01, and that'll be in grams per centimetre cubed. And there we go, there is our density question where we had a mixture involved. Okay, so looking at tangents to circles. Now these questions are pretty long, there's no way of getting around that. We just need to sort of figure out piece by piece here. Now this particular question says a circle has equation x squared plus y squared equals 25. Point P has the coordinate minus 3, 4, it lies on the circle. Alex says the tangent at P crosses the x-axis at -8, 0. Is Alex correct? And you've got to show how you get your answer. Now, in order to find out an intersection with the x-axis, we need the equation of the tangent. So this whole process really is finding the equation, and then we'll see if it goes through the x-axis. So it says point P has the coordinate -3, 4. The equation of the circle doesn't really have much impact. All that it tells us is it crosses, or the centre of the circle is at 0, 0, because any circle equation in that form is centred at 0, 0. So we just need to know where the centre is. If you wanted to draw sort of a little sketch of it, to sort of envisage what it looks like, you've got a circle centred at 0, 0, and -3, 4 is in this region just here. So this is what our tangent would look like. So -8, 0, what it's asking is this point here, is it -8? Essentially, that's what it's asking. So we need to go about finding the equation of the tangent. Now to do that, we have to find the gradient of the radius, as the radius meets the tangent at a 90-degree angle. In other words, it is perpendicular to the tangent. So the gradient of the radius is really nice and easy to find when the circle's centred at 0, 0, because the change in y is the y coordinate from 0 to 4 is 4. So the gradient of the radius is 4 divided by the change in x. And x goes from 0 to -3. So it's -4/3. And there you go, you can write that in either form. Now, when we are looking at the tangent has the negative reciprocal of that. So the perpendicular gradient, which I write as MP, lots of different ways that you can write that. I just write MP. So the negative reciprocal of -4/3 is +3/4, just flipping the fraction over there and changing the sign. So that's the gradient of the tangent. Now all I need to do is put it into y equals mx plus c. So y equals 3/4 x plus c. To find that y-intercept, you just substitute the coordinate that's given to you on that line. So -3, 4. So y is 4, and that's equal to 3/4 multiplied by -3 plus c. -3 times 3/4 isn't actually difficult to do without a calculator. You just multiply the numerator by -3. So we get 4 equals -9/4 plus c. Now we need to know the value of c. So we add 9/4 to both sides. So plus 9/4. So I'll probably do 4 plus 9/4 on my calculator. Don't necessarily need it, but it is going to speed it up a little bit. So we get 25/4 is equal to c. I can now write the equation of the line by putting that c value back into my equation, and we get y equals 3/4 x plus 25/4. So there is my equation. I now just need to use that to find where the line crosses the x-axis, that's where y is equal to 0. You can already see that anyway in this particular one because they've put the 0 there. So you've got two ways of showing whether this is correct. Either we put y is equal to 0 and we solve it and see what x actually is, whether it's minus 8 or not. The alternative is we could actually sub negative 8 in place of x and see if it equals 0. So it doesn't really matter either way. That might actually be the easier way in this particular question. However, had the question said find where it crosses the x-axis, we'd have to go for y is 0. So I'm going to go with that method because it's going to work for other questions, but it's not the only way of doing it. And then plus 25 over 4. So solving that, minus 25 over 4 to the other side equals 3/4 x. And then we need to do negative 25 over 4. I'm going to do this on the calculator and divide that by 3/4. There we go, just type that in. And we get x is equal to, I'm going to write that working out down just here though, divide by 3/4. And we get x is equal to minus 25 over 3 or minus 8.3 recurring. So the x value is not negative 8. It's very close, but it's not negative 8. And therefore, I've got to answer this question, is Alex correct? So I will say something along the lines of no. And if you want to write some more words alongside that, you can. No, Alex is not correct. And really clearly labelling that next to your working out to show why. And we've shown that pretty clearly there because we have x is equal to negative 8.3 recurring. Okay, so looking at equations of proportion. Now I like these questions here because as practice, they're really good. We get to practice inverse and direct proportion, but they're not the only kind of equations of proportion questions that appear. You might just have one. Now this one does have both, so it's a great question because we get to practice both, but just be aware they're not all like this. This is quite a tricky one. So it says y is inversely proportional to d squared. Now we have two equations of proportion. Now some people will write that using the proportion symbol. So for example, in direct proportion, so for this one here, you might have been taught to write this as d is directly proportional to x squared. If you use that, absolutely fine. Stick with it, please, because that is the method you've been taught. When I do this, I just go straight into my proportion formula. So I write y equals, for inverse proportion, k over d squared, rather than k times d squared. So I jump straight to the formula. Okay, now you don't have to do it that way, as I've said. So the next step is substituting in the values. So it says when d is 10, y is 4. So 4 equals k over 100, which is 10 squared. I've jumped straight to 100 there as well. Solving this to find the value of k, times by 100, and we get 400 equals k. Now when you get your value of k, don't stop there. Put that straight into the formula that we wrote at the start. So my first formula is y equals 400 divided by d squared. That is my inverse proportion formula, all set up and ready to go. The next one is a direct proportion formula. It says d is directly proportional to x squared, so d equals k times x squared, or kx squared. I can now sub the values in that I've been given. X is 2, d is 24. So 24 equals k. I am going to put a times now because I'm going to do 2 squared, which is 4. And I want it to be really, really clear there that to solve this we have to divide by 4. Now you can rewrite that if you want to get rid of the times sign. You could write it as 4k, but I would never typically write k4, not necessarily being correct. It's just very rarely ever see it written like that. So dividing by 4 to get our value of k here, and we get 6 is equal to k. Again, don't stop there, put it straight into your formula. So for my direct proportion formula, I get d equals 6x squared. So I now have my two formulas. Now just be careful when doing these. It doesn't happen very often, but I have noticed sometimes that because k is written in both of them, And obviously if we have the same letter in a question, typically that letter has the same value, whereas here we're writing two separate formulas for two separate statements. So just watch out for that, because some people seem to think sometimes when they've found the value of k in the first one, that's the value of k in the second one, but they're not. These are completely separate. So it now says find a formula for y in terms of x and give it in its simplest form. Now we do have a formula for y, it's up here, but at the moment it's in terms of d. It says y equals 400 over d squared. So at the moment our formula for y is in terms of d. To stop that from happening, we can replace the d there with what we have found out that is equal to, and it's equal to 6x squared. So all I'm going to do is replace the letter d with 6x squared, and when I do that we get y equals 400 over 6x squared, but it was d squared, so that whole thing is still squared in this question. 6x squared multiplied by 6x squared, well 6 times 6 gives us 36, and x squared times x squared would give us x to the power of 4. That is now a formula for y in terms of x. However, it does say give it in its simplest form. So I just need to have a look. As it's a fraction, is there anything the top and bottom divide by? And because I'm using a calculator right now, what I can actually do is just type in my calculator 400 on the top of a fraction, 36 on the bottom, and it actually simplifies it for me. I get 100 over 9. So I get y equals 100 over 9x to the power of 4. If there was x's on the top and bottom of both, potentially we could have to cancel off some x's, but that doesn't tend to happen in these types of formulas because k tends to be a number. But if it was a letter, because a letter had been put in here instead, you might have to cancel off some x's or another letter top and bottom as well. But there we go, there is our final answer. Y equals 100 over 9x to the power of 4, and that is inverse and direct proportion. So this question here is looking at the volume of cones and spheres. Thankfully you are given the formulas for those, so they'll be next to the question. So have a look at your formulas, just make sure that you are super happy with using them, finding your pi button on the calculator, and we're just going to work out anything that we can see. So this particular one here tells us that the total volume of the shape is 120 pi and the total height is y. So we are going to work out the value of y in this question. So here, when we're trying to find this missing height, well, we're going to have to work out the volumes. So if we go about working out one of the volumes, we can identify that we cannot work out the volume of the cone yet because we don't know the height. If we had y, then we could, but we do know the height here of the sphere or the hemisphere because it is the radius. So the radius goes from the centre of that hemisphere down to the bottom of the sphere here. So that's going to be half of the 7, so that's 3.5. So we do have part of the height already. We just need to work out that volume that's just the cone. So if we use the volume of a sphere formula, we have 4/3 pi r cubed. However, for a hemisphere, we can halve that as it's half of a sphere, and that's timesing this formula by a half. If we times it by a half, instead of being 4/3, and you can do this on your calculator, 4/3 times a half is 2/3, of course, half of 4/3. So 2/3 pi r cubed. So we can use that straight away. So 2/3 times pi times 3.5 cubed. That's going to give us the volume of the hemisphere. So we can type that in, 2/3 times pi times 3.5 cubed. That gives us a volume. It's not a particularly nice one. It comes out as 343 over 12 pi. So there we go. You could write the decimal version of that down if you wanted, but I'm going to leave it in terms of pi. So for this bit next, we're going to take that away from the total volume that's given to us, so 120 pi, minus this 343 over 12 pi, and that's going to give us the volume of the cone. So 120 pi minus the answer on the calculator, and that comes out as 1097 over 12 pi. So that right there is the volume of the cone. Our formula for the volume of a cone is right here, 1/3 pi r squared h, and all we need to do is work out the height. We have all the missing pieces, so we could set up the formula. We have 1/3, we're kind of running out of space here, let's do it down the side, 1/3 pi times 3.5 squared times the height is equal to 1097 over 12 pi. Just about fit it in there. And now to isolate the height, we can take all three of these pieces and divide those to the other side. So we get the height is equal to 1097 over 12 pi divided by, and then we have this 1/3 pi times 3.5 squared. Now I'd probably write that as a fraction on my calculator rather than as a division like that. Probably going to be a lot easier for us to do. So I already have the answer on my calculator, so I can put the answer over and then do 1/3 times pi times 3.5 squared. Now that gives me a final answer. It comes out as either a decimal or as a fraction. I'm going to write this one as a decimal. It comes out as 22.3877551. Okay, so that is the height of the cone, and to get the height of the overall shape, which we've got over here, we've got the 22.38, we're going to need to add the 3.5, which is the height of the hemisphere, and if we add 3.5, it comes out as 25.887, so 25.887, and we want that written to three significant figures, so that's going to be 25.9, and that's in centimetres, and there we go, that is our final answer, 25.9. So basically, just using your formulas, we had using the formula once, normally, for the sphere, of course only doing half of it though, as it was a hemisphere, and then we had a formula in reverse to find the height of the cone, and this one here wanted the height of the overall shape, so we've added those two together. And there we go, that's a bit of volume of cones and spheres. Okay, so in this question we're looking at angles in parallel lines. Now it says here that A to E, DBG and CF are parallel. D to A, D to B and D to C are all the same length, and we are shown that anyway because it gives us these additional lines on these triangles here, which straight away is telling us that they are isosceles triangles. It says that EAB is equal to BCF, which is also equal to 38. Work out the size of angle X, and you must show your working. So, for starters, there are sort of two sets of parallel lines put together in this one. And above and below this central line, they are identical. We know they're identical because we have that 38 above and below. But we want to have a look between two of the parallel lines to start with. We want to see if there's a connecting line that goes between the two, or we can find any alternate, corresponding or co-interior angles. Now the first thing that stands out to me is that we can make this nice Z shape which hooks in this 38 and gives us an alternate angle just up there. So this also has to be 38. Now it doesn't tell us to give reasons in this question, but here the reason that that is 38 is because alternate angles are equal. And in a lot of questions, it does ask you to give the reasons. We don't need to in this one, but just so you know, along our working out, that's why it's 38. Now we can almost now come away from all of this image, and we're going to now look at and sort of zoom in on this triangle here, because we've already said that's an isosceles triangle because two lines are the same length. On an isosceles triangle, base angles are equal. So this here is 38 as well. And although we're not giving the reason, we have base angles in an isosceles are equal. And that comes up quite a lot. So there we go, base angles in an isosceles are equal. We can now find the top angle within the triangle, so this one just here, because angles in a triangle add up to 180. So we can do 180, and again it does say you must show your working, take away, and then we have the two 38s, so 38 plus 38, you could work that out and then take it away from 180. I'm just going to type it all in one go, so 180, take away 38 plus 38 in brackets, and that gives us 104 degrees. So that one there is 104. Now, it's not always going to be like this, but because that is almost reflected up to the top, in other words, all of the angles above are exactly the same because it's the same diagram, just sort of flipped upside down on top, that means this here is also 104. So to find that angle x, that is the missing angle around a point. Angles around a point add up to 360. So to find our final angle here, we would do 360, the angles around a point, subtract the two 104s, so 104 plus 104, and there we go. We can type that in, 360, take away 104 plus 104, and that gives us 152 degrees as our final answer. And there we go. And if you wanted to write a reason along with that, it's because angles around a point add up to 360 degrees. And there we go. There were some angles in parallel lines and also involving some isosceles triangles. Okay, so this question is looking at a cylinder. It says here, Karina has 4 tanks on her tractor. Each tank is a cylinder with diameter 80 and height 160. The 4 tanks are going to be filled completely with a mixture of fertiliser and water. The fertiliser has to be mixed with water in the ratio 1 to 100 by volume. Karina has 32 litres of fertiliser. And it tells us here that 1 litre is equal to 1,000 centimetre cubed. Has Karina enough fertiliser for the 4 tanks? You must show how you get your answer. Well, for starters, we need to actually work out the volume of one of these cylinders. So the volume of a cylinder is the same as any other prism. You get the area of the cross-section and times it by the height. Now the area of the cross-section here is a circle, so we need to get the area of this circle. To do that, we want to know what the radius is. The radius is half of the diameter, so that's going to be 40 centimetres, and then we're going to use our formula pi r squared. Once we've done that, we'll times it by the height, and that's the volume of the cylinder. So if we work that out, that's going to be pi times 40 squared, and we can either type that in and then times by 160, or we can just times by 160 straight away. And let's just write that down then. So pi times 40 squared times 160, and that gives us a very large volume here, but we get 804,247.7193. And there we go, that is the volume of one tank, 804,247.7193 centimetres cubed. Now it says here that we are going to have 4 tanks. Well, she has 4 tanks, so we need to multiply this by 4. That's going to give us the volume of all 4. So if we press times 4 on the calculator, we're starting to get to some very large numbers now. That's absolutely fine though, just make sure we write them all down. So we have 321,6990.877. So that's 3.2 million centimetre cubed. Right, so we're getting some very large numbers. Now, it says here, Karina has 32 litres of fertiliser, and it's going to be mixed in the ratio with water 1 to 100. So we're going to need to work out exactly how much volume we have here, but that's given to us in litres, and we're currently working in centimetre cubed. So completely up to you. You could either convert the 32 litres into centimetre cubed and keep dealing with very large numbers, or we could turn this volume now into litres, and we can do that just by dividing by 1,000, as it's 1 litre for 1,000 centimetre cubed. So if we divide that by 1,000, at least we're going to get some slightly smaller numbers. So here in litres now, the 4 tanks is 3,216.990877, and that's now in litres. So that's how much space is in those 4 tanks. We just now need to work out exactly how much space we actually need. So the fertiliser is to be mixed with water in the ratio 1 to 100. So the fertiliser to the water is 1 to 100. Karina has 32 litres of fertiliser. So she has 32 litres, so we need to multiply by 32, which means we're going to have 3,200 litres of water. And the total there, if we add those two together, is 3,232 litres. So, has Karina enough fertiliser for the 4 tanks? Well, it does say the 4 tanks are to be filled completely with the mixture, so they have to be completely full. Well, Karina has 3,232 litres, and space-wise, she has 3,216 litres. So she has more fertiliser than she needs to fill the tanks. Only a little bit extra, but that does mean, yes, she is going to be able to fill the tanks. So we would say yes, and you could write next to that, she will be able to fill the tanks. You can write any sort of explanation you want with it, because she has 3,232 litres and the tanks are only 3,216. So she is going to be able to fill them. And there we go. That was a functional volume question dealing with cylinders and having a little bit of ratios in there. Okay, so in this question we're looking at some frustums. Now a frustum is made by removing a small cone from a large cone, and that is actually what we're told in the start of this question as well. You can see that in the diagram. But it says here the frustum is made from glass, and the glass has a density of 2.5 grams per centimetre cubed. Work out the mass of the frustum and give your answer to an appropriate degree of accuracy. That last line is quite interesting as well. An appropriate degree of accuracy. That means we sort of have an option of how we want to round it. So something like 1 decimal place maybe. So looking at this question then, can we get the volume of the frustum? Ultimately, it wants us to work out the mass. So we need to think about our density formula again. So we have density is equal to mass divided by volume. To get the mass, we need to do the density multiplied by the volume. We are given the density, so we'll just need to do 2.5 multiplied by whatever the volume is. So we'll leave that there and we'll come back to it. So getting the volume of this, I need to work out the volume of the frustum. We are given the volume of a cone formula, so I just need to work this out. To get the frustum, I need to get the volume of the large cone that used to exist before the top was sliced off it, and then we'll take away the small cone that was chopped off. So here we're going to do the large cone, and it's always good to label it, so I'll label it large and small. So that would be 1/3 times by pi. The radius here for the large cone would be half of 12, so that's 6. So times 6 squared. And the height of that large cone would have been 15. So there we go. I'll type that into the calculator. 1/3 times by pi times by 6 squared times by 15. And I'm going to leave this in terms of pi, because if I start writing down lots of decimals, there's a lot to write down, and as it's come out in terms of pi, it's much easier for me to leave it like that. So 180 pi. I'm now going to look at the small cone, the one that's been chopped off the top. But the small cone does take a little bit more thought process. Now we can see the total was 15 and this little height is 10. So the height of the little cone is relatively nice to find. That's got a height of 5. Now finding the radius of that cone, we need to think about what proportion of the large cone has actually been taken off there. And it's 5 out of 15. So this little cone, looking at the height, is 5 out of 15. And that is equal to 1/3. So it's 1/3 of the size in terms of proportion. So we're going to have 1/3 of the radius. So 6 divided by 3 to find a third gives us a radius of 2. So now we can find the small cone. So it's 1/3 times pi. The radius is 2, so times 2 squared times the height of the small cone, which is 5. Again, I'm just going to type that into the calculator. I've already got my old calculations there, so I'm just going to delete the 6, change it for a 2, and then delete the 15 and turn it into a 5. And there you go. It doesn't give us as nice a number writing in terms of pi. It gives us 20/3 pi, but that's still easier to write down than the 20.94395,102 that I'd have to write down otherwise. So there we go. That is the small cone. So to find the volume of the frustum, which is the whole goal here, because then we just have to times it by 2.5, I just need to do the 180 pi, the large cone, take away this 20/3 pi, which is the small cone, and if we work that out, 180 pi, subtract the smaller one, we get 520/3 pi. You could at this point write it as a decimal if you want. The decimal is quite a large one. It's 544.542 7266. I'm going to have to write that again because I've got to now times it by 2.5. So I'm just going to stick with using this 520 over 3 pi. Just feel like that's easier to write down. So 520 over 3 pi that we're going to times by 2.5, as that was our density, and we're doing density times volume. So times by 2.5, and that comes out as now a final answer. Now it does come out in terms of pi. However, it says to give your answer as a suitable degree of accuracy. So I'm going to write it now definitely down as the decimal version. So we get 1361.356817. Now, a suitable degree of accuracy means we're likely not going to give that to 5 decimal places. So it would be absolutely fine to sort of round this to, well, we could round it to 1,361. That would be suitable. You could have 0.4 at the end. You could even round it to 1,360 and have it to the nearest 10. It's actually fine for us to round it in lots of different ways. But there we go. I'm going to leave it as 1361. That was, of course, a mass, and we were dealing with grams. So that's 1,361 grams. But again, I think you'd be allowed anything between 1,360 and 1,362, you know, in terms of how you've rounded it. So there we go, 1,361 is our final answer. Now, our next question is looking at a circle theorem. It says here, ABDE is a cyclic quadrilateral. Well, great, because opposite angles in a cyclic quadrilateral add up to 180. ABC and EDC are straight lines. That's helpful because straight away we can see what this angle next to the 60 is, because that makes a straight line. It says, given that the size of EAB to the size of BCD is 2 to 1, work out the size of BCD. And you must show you're working. Right, let's just find this angle on the straight line, then I'm going to come back to that ratio. So this one on the straight line here, they've got to add up to 180, so that is 120 degrees. Right, let's go back to this ratio. EAB to BCD is 2 to 1. Let's highlight those. So EAB is up here, and BCD is over here. Now, if they are in the ratio 2 to 1, I would normally label that either using algebra or keep it as a ratio. I'm going to label it as algebra. I'm going to call it 2x and 1x, just so I remember I've dealt with that. Now let's see if there are any other angles that we can find. So straight away, opposite this 120, opposite angles in a cyclic quadrilateral add up to 180, so that would be 60 degrees. Now I've got to figure out where to go from here. So we have a large triangle. If we have a look, I'll highlight this large triangle here. And we know angles in a triangle add up to 180 degrees. So now that we've written those two angles in terms of algebra, we can actually form an equation. We have 2x plus 1x plus the 60, and we know that all of those combined have to equal 180 degrees. If we simplify that, we get 3x plus 60 is equal to 180. We can then take away 60 from both sides, so 3x is equal to 120, and then we can divide by 3, so 1x is equal to 40. So now we know that x is equal to 40, we can actually substitute that into the two angles. This one over here would be 40, and this one up here would be 80. And from there we could actually go ahead and work out some of the other angles as well. But this question says to work out the size of angle BCD, which was this one over here, where the 40 is. So our final answer is 40, and there we go, actually we've written that down here. So we'll just keep that 40 there as our final answer. And there we go, there was looking at some circle theorems. That one only focusing really on cyclic quadrilateral and the opposite angles being 180. Of course, there's lots of circle theorems that you need to look at, so I'll link the video in the description for this one for all the different types of circle theorems. Okay, so moving on to some vector proof. This one here says the diagram shows triangle ABC. A to B is 3A, A to C is 2B, which we can see, and B to E is 3 lots of A to C. Well, that's actually not labelled on the diagram, so we could put that on straight away. That's B to E, 3 lots of A to C. A to C is 2B, so that would be 6B. And there we go, that's 3 lots of A to C. It says D is the point on BC, such that B to D and D to C is 3 to 1. So that is out of 4 parts, so that is 3/4. and 1/4. So that's how far along the line it is. It says prove that ADE is a straight line. Now these questions where it's asking you to prove that something is a straight line, I would say are some of the nicer versions of these questions. So this is a relatively nice vector. We're going to have a look at proving that that is a straight line. But of course, as always, I will link in the description a video for some much harder vectors. It's still a difficult question, but it's not the worst of the vector questions that we could have. So here we go, prove that ADE is a straight line. Now whenever we are proving a straight line, I like to find the vector for the full line to start with. So to get from A to E, we could go up by 3A and across by 6B. And that's going to give us a vector straight away. So A to E would be the vector 3A plus 6B. Now, whenever we are looking at these vectors, and particularly when we are looking at proving that something is a straight line, we want to actually factorise that vector. So we can take 3 out, so it's 3 lots of A plus, and then it would be 2B. So when we're looking at a straight line, we want to find another vector that also has this A plus 2B. So that's what we're going to be looking for. We just need to decide which one we're actually looking. So in terms of which one to look at, we can pick one of 2 separate lines now. We can either look at this line here, and to complete that particular line, there's a couple of ways that we could go about that. We could go up the line here and across. That would be one way, or of course we could go down and all the way around the shape. Now the other line that we could have a look at is this one here. And to move along that vector, the direction that we would want to go is up 3A and down here. Or of course we could go across 2B and up from C to B. Now it doesn't matter which way you choose, as long as we make the first decision as to which way we're going to go down that line that has no vector on it. So from B to C. So if I want to find the vector B to C, and that means we're moving from B to C, so we'll have to follow this direction that I've started to go in, that I've highlighted. To get from B to C, I have to go from B to A, which is minus 3A, and then A to C, so plus 2B. And you can write that the other way around if you prefer, not to have as many symbols, but I'm going to leave it like that for the moment. So to get from B to D, which is 3/4 of the way down the line, if we had have decided to go C to B, the other direction, I'd only be going 1/4 of the way up the line. So it does matter which direction we're going in. So B to D is 3/4 of this minus 3A plus 2B. If we expand this bracket, we're just going to multiply the numerator by the numbers or the coefficients of A and B here. So we get minus 9 over 4A, just timesing that 3 by 3, plus, and then it'll be 6 over 4B. Now I don't need to simplify these fractions or try and be fancy with it at the moment. I just want to write the vector down, and I've got my vector B to D. Now I can get from B to D, I can get from A to D. So from A to D, all I need to do is add in that additional vector, that's A to D, 3A. So that additional vector here, 3A, allows me to get up to B, and now I already know the vector B to D. So for that one, I want to do 3A, and then I'm going to do minus 3/4A, this is just the vector above, plus 6/4 B. Now we are doing this with a calculator, so I can just do 3, take away 9/4, I can do that on the calculator, and that comes out as positive 3/4. So I get 3/4A plus 6/4 B. Now this vector here is the vector A to D, and somehow that needs to match the vector that we found over there, A to E. So a good job that we didn't try and simplify these fractions, because you can see quite clearly that both of these divide by 3/4, and that means we can factorise it. So that will be equal to 3/4 on the outside, brackets, that fits into 3/4 once, so 1A, and it fits into 6/4 twice, so 2B. And you can see straight away now we have that matching vector. So in terms of what we've got, we know that these vectors are parallel as they go in the same direction. So that A plus 2B signifies the direction that they are going in. and they both have that point D in common. They both go through point D. One of them goes from A to D, so it goes through point D, and the other one is A to E. So it's going through that point D there, so it must be a straight line. So there we go, that is our proof. We could write something like that, sort of linking these up and saying that they share a common multiple, or they share the same direction, and they share point D, so therefore they must be parallel, and therefore must be the same straight line. Now we can as well have a look at the other part of the line. We didn't necessarily have to do A to D. We could have done as well D to E. So D to E, in terms of doing that, it would be a little bit awkward in terms of the direction that we happen to have used here, because we would probably want to now continue using B to C. So we'd do a quarter of B to C, which would get us from D to C. Then we would minus 2B, then add 3A, and then add 6B, and that would move us all the way around. Obviously it would be easier just to reverse that vector and go 3/4 from D to B, and then 6B across. So we could do that as well, but obviously there's a lot of working out for each particular vector. So this is what we're looking for. We are looking for the two vectors having the same direction in their bracket, and there being a shared point when we are looking for proving if something is a straight line. But as I already said, there are so many different vector equations, particularly the ones that are involving ratios and unknown quantities. So I will link the videos for vectors in the description for the timestamp next to this particular topic. But there we go, that was a question on vector proof. Now for plans and elevations, this particular one is asking us to draw a side elevation, and that's from the direction of the arrow. So this shows the front elevation and it shows the plan. So the plan is from above and the front is from one of those directions. Now you can kind of, and you don't need to draw this, but you can kind of imagine what this shape looks like. Obviously I sort of am okay at drawing this. I wouldn't necessarily expect people to draw this diagram, but it can help just to sort of visualize it in terms of what it looks like, and it's almost like a staircase. So that's what this particular shape is. It's not asking us to draw a sketch of it, but you can see now from the plan, you can see this sort of part where there's 4 there, which is on the top here. We've got this next part, which is just there, and then this little step is this bit here. So that's what we can kind of see from above. Now, that makes it a lot easier when you can sketch it, but you don't need to sketch it, because if we are going to draw a side elevation, we know from the side it's going to be the same height as the front elevation. So I can actually just draw in the height, making sure it matches the front elevation. Now we can see here from this particular side that we're looking at it, that is this particular length just there. And you can see that's 2 squares along. So from the side, we would see those 2 squares, and then it would just be a rectangle. So it's the same height as the front elevation. We've got our rectangle drawn. The only thing that I need to add in to my side elevation here is every time there's a little change of height, we just need to add in an extra line at those 2 points. So I would add in an extra line here and also an extra line there. And there we go, that is our side elevation. So it does help drawing those just next to a front elevation. It does really help if you can visualise these. I wouldn't expect everyone to necessarily be able to visualise them, and just draw a sketch just like that. Particularly with this one, it's a relatively complex shape. But there we go, there is a question on plans and elevations. So for a Venn diagram, we just need to be very, very careful that we put the numbers into the appropriate places. This one has a lot of numbers to use. It says odd numbers less than 30. So I would always recommend, even with a question like this, where there's a lot of numbers that are involved in that, to just make sure that you write all the numbers down. It's always very frustrating when you put all of these numbers into a Venn diagram and then you realise that you've actually missed a number off the list. So although this is a very long one, we're going to write all those numbers down, then cross them off as we go. So it says A and B. Now sometimes these are given as descriptions. For example, B might have said multiples of 5 there, but it's given us 5, 15 and 25. The important part is all the numbers that are in this section here have to go into the Venn diagram somewhere. So if we look at what's in both, there is a 15 in both, and that's it. So 15 would go in the middle. We are then told in B we have 5 and 25, and we will need to label this Venn diagram if it's not labelled, so we'll have B on the right, and on the left we have the 3, the 9, the 21
and the 27. Now if I go through my list, crossing these out, we've used 3, 9, 21, 27, 15, 5, and 25. And all of those remaining numbers need to go around the outside. So 1, 7, 11, 13, 17. We've also got 19, 23, and 29. And make sure that you've written them all in. I would even go back now and cross off the ones as you can see that you've written them, just to make sure there's definitely not a number there that hasn't been crossed off. It now asks us in this particular question that one of the numbers is chosen. What's the probability that it's in set A, U, B? Now the U stands for the union. So when looking at the union, we are looking, in terms of the circles, everything that is within the circles, including the intersection there in the middle. We are just not looking at any numbers on the outside of those circles. For the N, which stands for the union, in the case of the union, we are only looking at the intersection, so the numbers that are right in the middle there where they cross over. So here, as we are looking at the union, there are 1, 2, 3, 4, 5, 6, 7. There are 7 numbers in total that we would select out of a total, and obviously we've got the big long list up there so we could go and count them, 3, 6, 9, 12, 15, so 7 out of 15 numbers are in the union. You can also be asked numbers that are not in a particular circle, and something like that might say in B and it has a little dash with it, and that little dash means it's not in that circle. Now you have to be a little bit careful because sometimes people get the intersection confused. If it's not in B, then it can't be in the intersection. If it's not in A, then it also can't be in the intersection. So any numbers here that are within this B circle are in B, so we'd only be looking at the numbers outside of that. So outside of that circle, well, there's 3 in the circle, so there's 12 numbers outside of that circle. So that'd be 12 out of 15 if it was looking at numbers not in B. Just be a little bit careful with that. There's lots there in terms of the set theory, just to make sure that you know all of those. Okay, and on to some probability equations. There's lots of different variations of this question. I will link a video in the description so you can check out some different variations. But this one here says that there are n red sweets in a bag and 8 yellow sweets in a bag. It says one of the sweets is going to be taken from the bag, eaten, and then a second sweet is going to be taken. Given the probability that both sweets will be red is 3 out of 5, we need to work out the number of red sweets in the bag. So of course we have this unknown amount, and when we're working out probabilities like this, we tend to use a probability tree. So if we were to visualise what the tree would look like, we have a red or a yellow, and then we're going to have a second pick where there is going to be a red or a yellow. Now in this particular question, we're only concerned about one of those roots, red and red. And rather than drawing out a whole tree here, because we're going to have some algebraic probabilities, it's better that we just think about the route that we actually want to take. So if we have n red sweets and 8 yellow sweets in total, that is n plus 8. So our probabilities to start with will be out of n plus 8. So here we have red being n, so it's n out of n plus 8. If one of those red sweets is taken, then the numerator will go to n minus 1, and the denominator will go to n plus 7, as we've taken away 1 from the denominator as well as the numerator. Now to work out that probability, we would multiply those two together. So we would have n over n plus 8 multiplied by n minus 1 over n plus 7, and it tells us that that's equal to 3 over 5. So now we have essentially an algebraic fraction problem to solve. So we need to multiply the numerators and multiply those denominators. Now if we do that, the numerators, n minus 1 times n, would become n squared minus n. And the denominator there is a double bracket, n plus 8 times n plus 7. Now you can write that out as a full double bracket. It gives us n squared plus 7n and 8n together makes 15n. And then 7 times 8 is 56. And again, that's equal to 3 over 5. From here, we would need to cross multiply these denominators to turn this into a nice straight line equation that we can solve. So 5 lots of n squared minus n gives us 5n squared minus 5n, and 3 lots of that denominator, n squared plus 15n plus 56, gives us 3n squared plus 45n plus, and then 56 times 3 is 168. So we now have a quadratic equation to solve, and we need to make that equal to 0. So we need to move all those pieces on the right over to the left. So subtracting 3n squared from both sides gives us 2n squared. Subtracting 45n gives us minus 50n, and then minus the 168, and that's equal to 0. Now from here, you could use the quadratic formula, or we can have a look to factorise. It should be a whole number that we get, so we should be able to factorise this. If we divide both sides by 2 to make it easier to factorise, we get n squared minus 25n minus 84, which is equal to 0. And then we just need to figure out what numbers are going to go into our brackets here. So we want the factor pairs of 84. So for 84, we could have 1 and 84, 2 and 42. And as we go through, let's just think about whether we can make 25. We can't yet. 3 goes into 84. 84 divided by 3 is 28. And we can make 25 using 3 and 28. So we want to make negative 25. So minus 28, add 3. And there we go, that would make negative 25, that's equal to 0. So we get 2 solutions here, n is equal to 28, and n is equal to negative 3. Now in this scenario, where n is a real life thing, we can't have negative 3 red sweets. So our solution has to default to this positive value. So the answer here, n is equal to 28, and that is the number of sweets in the bag. And there we go, that is working with a probability equation. Okay, so looking at angles in polygons. Now this is an irregular polygon, meaning that all of the angles are clearly not the same size. But it does tell us that angle AED is 4 times the size of angle ABC. So this angle over here, and this angle over here, where the E is, that angle is 4 times the size. Now you could approach this like a ratio, or you could write these in terms of algebra. So if the smaller angle is 1x, 4 times the size of that over here would be 4x. It says work out the size of angle AED, which is that larger angle there, and you must show your working. So a pentagon, and we can see the shape anyway, but a pentagon has 5 sides. Our formula for working out the size of the sum of the interior angles is n minus 2, where n is the number of sides, so 5 minus 2. And then you multiply that by 180 degrees. That comes out as 540. So in this question here, relatively nice in the sense that we just need to work out what's missing. So in total, we have 120, 135 and 110. I can add those up on the calculator. So 120 plus 135 plus 110, that gives us a total of 365. So if we subtract 365 from 540, that tells us what's left over, and it leaves us with 175. Now split between these two angles, 4x and 1x, in total we have 5 lots of x. So we have 5x is equal to 175. From there we can find the size of 1x by dividing by 5. So 175 divided by 5 leaves me with 35 degrees. And I can now substitute that into those angles, meaning this angle here is 35 degrees. And this angle here is 4 times 35, which we can again do on the calculator. And that comes out as 140 degrees. So for this one here, AED is 140 degrees. And we've shown all of our working there. And that is angles in polygons, and that was a particular type of polygon, which was an irregular polygon. For these worded probability questions, it's not always the best idea to draw a probability tree. So we'll have a think about how we could do this without a probability tree. But it says Ray has 5 odd numbered cards and 4 even numbered cards. Ray takes at random 3 of these cards and he works out the sum of the numbers on the 3 cards and records the result. Work out the probability that the result is an even number. So if we think about types of numbers, in order to get an even number, if we have only odd and even as our options, if there's only one odd number, then this is going to give us an odd number when we add them together. And you can test some numbers out. 4, 6 and 3 adds up to 13 because we had one odd number there. But if we have two odd numbers add together to make an even. So in terms of roots or options of cards that have either no odd numbers or two odd numbers, we could have a nice combination to start with would be they're all even. We could have even, odd, odd, and we can have any combination of that. So we could have odd, even, odd, or odd, even, even. Not odd, even, even. That's two there. Odd, odd, even. There we go. Odd, odd, even. So those combinations there have either three even numbers, which gives us an even in total when we add them all together, or we have these combinations here where there's two odd numbers, and two odd numbers will give us an even number combined with that other even number. But any other combination that we go for would only have one odd number in, and that would give us an odd answer. So this is a kind of question here, and there's so many different types of these. We could look at the difference between the numbers. We could look at the product of the numbers potentially in different types of questions. And all of those things could create a different result. So we have to sort of run through that concept in our head. The alternative to doing it this way would be to draw a giant probability tree, and they can get very, very messy. This one isn't too bad because there's only two options. You could have odd and even, first pick, and then you have odd and even, and then off each one of these you have odd and even. But what happens is you end up with quite a large tree, and if there are three things at the start and three picks, this can get very, very, very messy and very time consuming in an exam. So if you want to use a probability tree because the question is something which the probability tree isn't going to be too bad, then use a probability tree. But if you think about doing this without a probability tree, you should be able to tackle any question, even if they're a bit more complicated. Now, that being said, this question here, I think it would probably be fine to draw a probability tree, but we'll think about this method instead. If you want to use a tree for it, you go ahead. So if we're going to take this approach, there are currently 5 odd and there are 4 even. Now if we think about that, that means that this is out of 9 cards. So on our first pick, if we go for this even, 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 if we sort of label these up, look, 1, 2, 3 and 4, these are the 4 options that we need to work out. For option 1, 3 even cards. Well, there are 4 out of 9 even cards. Now if I take one of those even cards on the first pick, this drops down to 3 and this drops down to 8. So on the next pick, it would be 3 out of 8. Now again, what I could keep doing is continuously crossing that number out, and if it helps, you can draw little pictures if you want. Draw 5 little circles with the O in, and 4 little circles with the E in, and then every time you take one, just cross one out. So you could draw a nice visual of this. But another even number would just be now 2 times, or 2 over 7 times 2 over 7. Now that there is going to give us our answer for the probability of picking 3 even cards. 4 over 9, 3 over 8, 2 over 7. The even number just dropping down by 1 each time. Now I can type this one into my calculator. So times 3 over 8 times 2 over 7. That one there is quite nice. It does come out as 1 over 21. The calculator simplifies it for me. Option number 2 does get a little bit more complicated because we go back to the beginning. We're now back to being out of the 9 cards. Let's see if we can get rid of that without deleting it all. And there we go, back to 9 cards. So option 2, even to start with, so 4 over 9 again. Now we go on to the odd cards. There are 5 odd cards, but one has been taken out, so it drops down to 8. You will start to spot a pattern. The next one's, of course, going to be out of 7. But in this next option, when we take an odd card, one of the odds has gone. There were 5 odd to start with, so now there's 4. So because every time it just drops down by 1, I can start to at least apply a little bit of a pattern. So I'm just going to type this one in on the calculator, and that gives me 10 over 63. Option number 3, odd, even, odd. There are 5 odds, so 5 over 9 times even, 4 over 8. One of the odds has gone for this final pick, so 4 over 7. And have a look, see if these match any of the others. The one above, look, if you have a look, we've got 544, that was 454, so we're going to get the same answer. So we get 10 over 63. That'll save me typing it all back in again, and we can go on to the last one. Odd, odd, even. So odd, we have 5 over 9 times odd again, 4 over 8 times even, there are 4 evens, so 4 over 7. That's the same as the calculation above. 5 times 4 times 4 on the top, 9 times 8 times 7 on the bottom. So again, we get 10 over 63. Now, if you want, you could actually write this one over 63, times it by 3, it would be 3 over 63. So they are all over 63. All we need to do is take our 4 options and add all of those together. Make sure you write the working out down. 3 over 63 plus 10 over 63 plus another 10 over 63 plus another 10 over 63. We've got lots of them. And overall there, 10 plus 10 plus 10 plus 3 gives us 33 over 63. And there we go. That is our final answer for that probability tree. Now, obviously, if you prefer to draw a tree, feel absolutely fine. But when you think about the amount of working out that I've done there, I would have had to have written all of that as well as the tree. So it's definitely less working out. It's just whether you can visualize or apply a method that allows you to do that without a tree. Again, my suggestion with drawing the counters at the start, like this, you could just do 1, 2, 3, 4, put E on each one, and then as you take one out, just cover it up with your finger so you can visually see how many are left. The important part was that bit at the start though, figuring out what are the actual roots that we need that will give us that desired outcome. In this case, getting an even number when we add 3 numbers together. So there we go, that was a probability question looking at worded probability. Okay, so in this question we are looking at some circle sectors. It says OAB is a sector of a circle, centre 0 and radius 7, and we can see that on the diagram. The area of the sector is 40 centimetres squared. Calculate the perimeter of the sector, and we'll give it to 3 significant figures. So the area of this sector is 40 centimetre squared. So as we are given the area, which is 40, we need to apply the area of a full circle onto this sector, and then we'll try and figure out what proportion of the full circle this is. So if it was a full circle, we would do area equals pi r squared, where the radius is 7. So if we type that into the calculator, we'll do pi times 7 squared. Now, of course, we could write that in terms of pi, but we are given a numerical area here, so we'll write this as a decimal. It comes out as 153.93804. Now, 40 as a proportion of the full circle, so we could write it as a fraction of the full circle, or we could write it as a percentage of the full circle. But either way, we want to try and find out what is the size of this angle, x, so that we can find the length of the full perimeter, which means we're going to need to eventually find the length of this arc. So a couple of ways that we could do this. Now, we could set up a formula. So we could say, well, 40, the area of a sector, is equal to pi r squared, or pi times 7 squared, or 153.93804, multiplied by the proportion or the fraction of the full circle, x over 360. So that's one way that you can do it. I do quite like this way because it works every time. Or we could think of 40 as a fraction of 153. Now we do that anyway with this formula, because in order to solve this for x, we have to divide by 153.93804, which is essentially just writing now 40 out of this 153.93804. So in the process of writing it this way anyway, we still find what is this as a fraction out of the full circle, so something over 360. Now again, at this stage, essentially, to solve it for x, it's one quick step, so there isn't really much point in doing it a different way. A non-calculator style method, we think, okay, well, how do we get from 153 to 360? And then we just do the same to 40, and that tells us the angle. But we'll actually get our answer anyway, straight away with a calculator here, just by timesing by 360. So if we type that in, 40 over the 153.9, and then multiply that by 360 on the calculator, and we get the value x equals 93.544. Now there are a few more decimals there, but the answer is only needed to 3 significant figures. So I'm just going to leave it to 5, but I'm going to leave the answer on my calculator and use the full answer anyway. So that's the size of the angle. We have 93.544 degrees, and we need to find the perimeter. So we're going to revert now onto the circumference formula. So circumference is pi times diameter, or pi times 2r, and that will give me the circumference if it was a full circle. So the diameter is 14, double the radius, or of course you can use the 2r formula anyway. So pi times 14, and if I type that in on the calculator, pi times 14 is 43.98. However, I don't want the full circumference, I only want the fraction that we're looking at. So I can do it in one step. Now the fraction we're looking at is 93.544 out of 360 degrees. Now that is going to, instead of giving me the full circumference, that's only going to give me the length of the arc that we're actually looking at. Now I deleted that 93.544 number, so I'm going to have to type that back in. There we go, over 360, and that now gives me 11.4285, and I'm going to stop there again because it does only want it to 3 significant figures. So that's the length of the arc up here, 11.4285. Now the full perimeter is going to be the 7, and the 11.4285. So I want to add all of those together. So 7 plus 11.4285. And if we add 14 to the answer on the calculator, that gives me a perimeter of 25 point, and it's 428. So 42, so 25.4, it's in centimetres, so 25.4 centimetres, and that is the perimeter of my circle sector. And there we go, that is how to work out a little bit of front and backwards or forwards and reverse circle sectors. Now, of course, you could have that the other way around. It could have said the perimeter is 25.4. Now, in that case, we'd have done basically the same thing. We've had to have subtracted the 14 first, which would have given us the arc length, and then we'd have used the exact same process, but starting with my circumference formula, and then reversing over to the area formula. But it could be done either way, but there's a really nice circle sectors question. Okay, so looking at describing a transformation. So it says here, describe the single transformation that maps triangle A onto triangle B. Now with this one here, you can see the shape has changed size and it's rotated. So this only happens when we do an enlargement with a negative scale factor. So this particular question here, we have to actually find where that centre of enlargement is, and we need to find the scale factor. To find the scale factor, we can look at the length of the shape, as long as we match up the same side. So here the length is 2, and down here the length is 3. So to find the scale factor, we could either write that as a fraction, 3 divided by 2, or you could type that into your calculator or convert it into a decimal. So our scale factor is 3 over 2, but it's a negative scale factor, so it's minus 3 over 2, or minus 1.5. To find the centre of enlargement, we typically, with one of these ones, the way I would do it is join up the similar sides. So you've got this where the right angle is that you can join up to the other right angle. So that one there joins them up quite nicely. You just need to pick one other similar side. So I'm going to go with this one here and join that up. And you can see where they cross over is the point where the centre of enlargement is. So our centre of enlargement in this question is 1, 1. So when writing the description for this, we'll say it's an enlargement. We'll say the scale factor. So scale factor minus 1.5 and where it's enlarged from. So I'll put from the point and then we'll label that as 1, 1. So there we go, that's how we'll go about creating our description for a negative scale factor enlargement. Now, had it been the other way round and it had said, enlarge shape A from the point 1, 1, scale factor negative 1.5, what we do is count to the point. So this is 1, 2 down, and then 1, 2 to the left. We times that distance by 1.5, so 3 down, 3 to the left. We just do exactly the same through the point, so 1, 2, 3, 1, 2, 3. And you just repeat that for every single point. And you'll find that all three of those line up with triangle B there, and then we would draw it in. So that's how we describe an enlargement with a negative scale factor. And a very quick explanation now on how we actually do the enlargement ourselves also. And looking at a velocity time graph or a speed time graph, or this can be anything else that sort of links through to time. This particular one is a speed time graph, and it says a car moves from rest. The graph gives information about the speed of the car after it starts to move. Calculate an estimate of the gradient of the graph at t equals 15. Now it might not say calculate an estimate of the gradient, it might say something else, and that's what part 2 is relating to here. It says describe what this represents. Now the gradient of a graph represents the change in this thing here, which is speed in this case, by this thing here, which in this case is time. So it's a change in speed per second. Now a change in speed per second does have a fancy name. It's called acceleration. So this one here, we could answer this already. Acceleration. But it can just be described as a change in speed per second. That's quite a good one if it does relate to something else. So if it's not necessarily about speed, it could be about something else entirely. We can use the language that's on the axes to describe that. So this one here, not too bad. But it wants us to find the gradient at t equals 15. So I want to trace up really carefully from 15, make sure that I know exactly where the point is. I'm going to draw that tangent to the point so we can get the gradient. So I'm going to draw it at this point here. So we get our ruler, line it up underneath, and now this one's going to be a little bit tricky for me to draw on here because I can't actually do a ruler perfectly, but it's going to look something like this. Now I'm never going to get it perfect, but it should just touch the point, and you should see that you have around about the same sort of gap between the line and the curve either side. So there should be a little bit of a gap that you can see either side. Now what we do is we're going to draw a right angled triangle. I'm going to draw it above because we have a part B here that wants us to look at the area underneath as well. So we draw a right angled triangle in, and then I need to read the length of those, and I'm going to use rise over run, or change in y over change in x, to find the gradient. So the rise there, for me, let's have a look, every 2 squares is 1 on that axis, so it goes from 14 up to 20. So that has a rise of 6, and it has a run that goes from 10 across to what looks like 16, so that looks like 6 as well. So for my particular numbers here, which obviously would change if I had this on paper and I was using a ruler to do it, I would have a slightly different number. But for me, my rise is 6, my run is 6, and I get a gradient of 1. Now, of course, you want to check that really carefully. I do think actually I've got that number wrong there. Let's just have a look. It's not 6. I can just about see it. Let's try and get a bit more of an accurate reading. If I trace down with a ruler, and this is how I'd probably advise doing it, try not to draw too much all over this so we don't have to rub it all out. But actually, yeah, that's way past 16. So good job we've read that carefully. It goes every 2 squares is 1. So we have 16, 17, 18. There we go. So actually, it had a run of 8. So 6 over 8. Let's type that into the calculator. 6 over 8 is 0.75. So 0.75. We get a much more accurate gradient there. So yeah, be really, really careful when you're reading the scale. Definitely trace down, because they are not as easy for me on the screen, but when you've got your paper and you've got your ruler in front of you, you can trace down really nicely. So there we go, that is the estimate there for the gradient, and it represents, in this case, acceleration, or a change in speed per second. Now part B says work out an estimate for the distance travelled. Now to work out the distance travelled, we need to find the area underneath the curve. Now it says here to do it in the first 20 seconds, and to use 4 strips of equal width. So up to 20, we'll have our first line here. If we're using 4 strips, then we want to do that every 5. So 5, 10, 15 and 20. And that's going to create 4 shapes underneath. We have a triangle at the start and 4 shapes in total, 3 of those being trapeziums. So we want to label the heights of each one. We have a height of 4. Make sure I read these very, very carefully. The next one is a height of 12. The next one I can just about trace along and see that. I think that's 18 there. And the last one is 20. So we want to use the area of a trapezium formula for those other 3. The triangle, we can do base times height divided by 2. So the base there is 5. So 5 times 4 divided by 2. That gives me the area of the triangle. For the trapezium, add together the 2 parallel sides. So 4 plus 12 divided by 2 times by the height, which is 5, the distance between them. And then replicate this for the others. So 12 plus 18 divided by 2 times 5. And the last one, 18 plus 20 divided by 2 times 5. So when you type these all into the calculator, for a few of them, we can probably get the number quite easy. 5 times 4 is 20, divided by 2 is 10. We have 4 plus 12, which is 16, divided by 2 is 8, times 5 is 40. 12 plus 18 is 30, divided by 2 is 15. 15 times 5 is 75. And then 18 plus 20 is 38, divided by 2 is 19, times 5 is 95. So the total, we have 10 plus 40 plus 75 plus 95. We can add these all together. 10 plus 40 plus 75 plus 95. And that gives us a total of 220. The units are just here. It's meters per second. So that's 220 meters. And that is the distance the car travels in the first 20 seconds. And we found that by finding the area under the curve. And obviously just a reminder there, read those numbers on the axes very, very carefully, because as you saw with me, I almost made a mistake on there as well. So definitely trace down with your ruler, reading those numbers super, super carefully so that they are as accurate as possible. And that's our velocity time graph.